I'm a systems engineer at NASA JSC. I work along with Kirk in Building 8 there, and I guess I'm looking to get a better understanding of networking and Cisco network.
Great. So have you worked on Cisco devices?
Yes, we have a couple of Cisco switches. Also use Polycom Cisco codecs.
Okay. Yes, Craig.
Well, like Daniel said, we work together here at Johnson Space Center, and I'm just to learn as much as I can provide a backup role.
Are you able to see my screen?
Yes.
Yes.
CCNA. CCNA is associate level course. In CCNA, we have different tracks. For example, we have routing and switching. We have security. We have wireless, data center, collaboration, service provider, cyber security, okay. So we are going to discuss CCNA routing and switching. In CCNA routing and switching, we have to study two books, ICND1 and ICND2. There is an exam code 100-105 and 200-105. If you want to give separate examination of ICND1, you can give. Separate examination of ICND2, you can give. There is a combo examination.
I'm sorry. Are you expecting us to have a book?
Yes.
Okay.
So have you received any email from Cisco?
Well, I received an email from Cisco that I downloaded, but I just noticed a email from Adil Faraz saying that there's some issues sending us the courseware. So I just want to make sure that we have what we're supposed to.
Okay. So in that email, have you received any credential to log in into the Cisco?
Yes, I did that.
Okay. Because see, your course material will be online. You have to authenticate yourself, right? Whatever username and password you receive, you have to log in with that username and password, and then you are able to open your courseware.
And that's for the lab guide and the student guide.
Kirk, you're breaking up pretty bad.
I said that was for the lab guide and the student guide.
Kirk, your voice is not clear.
Yeah, the two documents that I got was the CCNAX.
Yes, there will be one student guide and one lab guide.
Yes, yeah, I have both of those.
Okay, Daniel received that thing. Crick, have you received that email? Daniel, you have both the guides, right?
Correct.
Okay. Okay. Uh, you will receive one more email. In that, you will get the lab access details.
I think he's having trouble sending those to us.
Yeah. Just a second. Let me check. Okay. Have you received? I sent you some links on your chat. There is a username and password to access the labs. Have you received that thing?
Yes,
Daniel?
yes, I can see it pulled up. Do you want us to try to log in?
Yeah. Once try to log in. Are you able to log in virtual labs or not? Let's verify that thing first.
Do you want us to use the username and password that you put there, or our system use? Okay, that's
No. Separately, I share the username and password on your chat. So Daniel have different username and password. Crick is having the different username and password.
Okay, I only see one username and password.
Let me show you that. Are you able to see my screen
Yes.
now? Okay. So you have to give the username and password and you have to submit. If you are getting some options like trainer token access, just leave it blank. Below there is an option skip option is there. You can skip that thing. Accept the license. Once you log in, then you will get these 53 discoveries.
I see it. I'm logged in.
So these are the virtual labs which we have to do. These are online racks from the Cisco. We are directly accessing labs from the Cisco right now. Apart from that, I will share some simulators. You can do all those labs into the simulator also. Have you heard about Cisco Packet Tracer? GNS3? If you want to give a separate examination of ICND 1, you can give this examination, and ICND 2, this is the exam. If you want to give a combo examination, the combo examination code is this. In the exam,
Yeah, we don't see you, bud.
Can you hear me now?
are you able to see now?
There we go. We can.
Okay.
Yes, I can see
Strong now. Yeah, Kirk, I can hear you.
In the exam, there will be 50 to 55 questions. And the question will be multiple choice. You will get a question, and there will be some options. You have to select the best option. Then simulations. In the simulations, you will get a scenario. In that scenario, there will be some fault. You have to correct the fault, and you have to enter the current configuration. Simulates. In the simulates, you will get a scenario, and they will tell you like you are unable to communicate from host A to host B. After that, they will give you the show running configuration of some devices. Based on that configuration output, you have to identify the problem and you have to identify the solution. Drag and drop. In drag and drop, maybe the question will be like that. They will give you two pictures, for example, like router and PC. They will ask what kind of cable will be there. So in your right side, you will get all the type of cable like cross cable, straight cable, rollover cable. You have to drag the correct cable between the devices. Clear this thing? Your exam time will be 2 hours 20 minutes. And in the exam, you will not get the review option. Means once you submit the question, that will be submit permanently. You cannot go back to the previous question. Clear this thing? Okay. Let's start the topics. In this CCNA, firstly, we have to discuss the basic of networking. In basic of networking, we'll discuss about the type of network, then we'll discuss about the topology, cables, network devices, OSI reference model, TCP IP model, then IP addressing, subnetting, supernetting, VLSM. Types of network, OSI reference model, and TCP IP model. Then topology, cables, network devices, IP addressing. In IP addressing, we'll discuss about IP version 4 as well as IP version 6. But at this time, we'll discuss only IP version 4. IPv6 we'll discuss at the last day. After that, subnetting, supernetting, and VLSM. So we'll try to finish everything, this content on the day 1. Sorry. So this will be complete the theory part. Once this basic part is done, then we'll start iOS, Inter-Network Operating System. So in iOS, we'll discuss about basic CLI commands, backup and restore, securities, routing. In the routing, we have to discuss static routing, default routing, and dynamic. In dynamic, we'll discuss about RIP protocol, EIGRP, and OSPF. So on day 2, we'll try to finish till EIGRP. On day 3, we'll continue with the OSPF. Then BGP protocol. Then access list, NAT, network address translation. Then DHCP. Once all these topics are done, then we'll start switching. In switching, we'll do VLAN, access and trunk link, inter-VLAN routing,
Just me, or did everybody else get kicked?
sorry?
I got disconnected somehow and then I reconnected. I was just wondering if it was everybody or just me.
No, it was just you.
Okay.
Because till now, we are just discussing what topics we are going to discuss in this CCNA course. On day 4, we'll continue with the switching. So there will be DTP, inter-VLAN routing with multi-layer switch, then we have to discuss VTP, VLAN trunking protocol. After that, STP, spanning tree protocol, Ether channel, HSRP, switch port security, span, syslog, on day 5 we had to discuss WAN. In WAN we'll discuss about the WAN technology. Then GRE, triple P and HDLC, IPv6, basic introduction to QoS, basic introduction to SDN technology, SNMP,
Hey, this is Kirk. I have a question.
so there are some small topics like CDP and LLDP. So these will be your content in these 5 days.
I think Kirk had a question.
Yes, Craig.
So I'm just curious. You said you're going to cover just some basic introductory things on day 5.
Craig, actually your voice is not clear.
While he's trying to clear that up, is there a way we can, the book titles, is there a way we can download those as a PDF form instead of?
No. That actually previously Cisco is giving the hard copy, right? Now hard copy is not there, so Cisco is giving these web links to access your course material. You cannot download that thing.
Okay.
And Cisco
It's
is
timing out. That's what I'm worried about.
not giving to print out also. If you take the printout, it will give you the option of you can take a printout of one lesson like that.
Oh, I see. I think Kirk sent you the question in chat.
Yeah. Will introductory topics on the day 5 will be included on the exam. Yes, whatever topic I written here, everything will be in the exam. So on the last day, I will show you some questions, like practice questions. Plus, I will give you some lab exercise, right? So similar lab exercise will be in your exam. So most probably from tomorrow, we'll start doing all the labs. We'll start the lab today also, but from tomorrow onwards, there will be every topic. Let's say if we are discussing the RIP protocol, then there is a separate lab for the RIP. If we are discussing EIGRP, there is a separate lab for EIGRP. Clear this thing? Any question? Okay. So first thing is network. What is network? Any idea? So network is a group of 2 or more network devices connected to share information and resources. Network devices can be PC, can be servers, can be firewall, can be switches and routers. Can be access point, WLC wireless LAN controller, types of network. LAN, MAN and WAN. Daniel, are you there? Crick, are you able to see my screen? Okay. Yes, Daniel, are you able to see the screen? Everything is working fine?
Yeah, everything from Cisco keeps timing out on me.
Okay. So network is a group of 2 or more network devices connected to share the information and the resources. Network devices can be your PC, can be servers, can be firewalls, switches, load balancer, access point, WLC, wireless LAN controllers. No.
Are you just going over a brief explanation of what we're going to do now, or are we supposed to be following along with something?
So we are doing like firstly we will do introduction of technology, for example, like basic of the network, then OSI reference model, and then we'll do all the labs.
Right. No, I understand that, but is there documentation that we're supposed to be following along with you?
Okay.
Book?
See, basically in the book, the topics are not in the systematic way because that book is the combination of ICND 1 and ICND 2.
Okay.
And we have 5 days. So the duration is short and we have to do all the topics. So I'm going into the systematic way. Firstly, I will do the complete basic things so that when you are doing the routing part, then you should know like what is the subnet, what is the routing process, how we have to calculate the subnet. Clear? So firstly, we'll do the basic part, then we'll move to the routing, then we'll finish the routing, then we'll do the switching, and then securities, and then WAN. If you see the book, okay.
I can't see your screen right now.
Let me show you one thing. Daniel, can you share me your screen?
Yeah.
Share your screen and share the PDF. You just log in into the PDF. Let me show you that.
I keep logging into it. It keeps timing out. Like right now, the Cisco website is completely locked up on me. Like I have the lab thing open, but the
Are you getting any error message?
I am.
Share your screen. Let me share.
Hang on just a second. I'll see.
Hey Daniel, are you using the e-reader or the website?
I believe it was the website.
Okay, so I downloaded the e-reader and there are 2 books and it just stays there. It doesn't time out or anything.
Yeah, no. So from the link that they sent me, hold on a second.
Okay, not an issue. Crick, you can share your screen.
Like I've completely lost connected to y'all. I see trainer. That's all I see. I don't even see the rest of y'all's stuff.
Click share your screen. So open this book. Just show me the content.
Yeah, that's the one that's giving me an error.
Okay. Next. Next page. Next. Next. Okay. Next. So right now we are going to discuss this thing. But if you see this complete book, somewhere there will be an index in which you are getting all the topics. Where is that thing? Indexing. So just hold on. If you see this thing, click just approve.
So Kirk, how did you get away from the web thing? Because I think that's what's getting me.
Okay. So if you see this book, in this they are starting with the Cisco CLI functions. So directly they are moving to the devices. So they are not discussing here like what is the network, what is the subnetting, what is the basic requirements, right? So what we are doing, we will do from the basics and we'll complete all these topics. Okay. For example, if you see here, they are starting the switch on the first day. If you don't know like how the switch will behave, what are the basic functionality of the switch, then how you will configure those switches, right? So everything I will do, but in a systematic way. So firstly, we'll do the basic introduction to the technology. Then we'll discuss about the routing part, then switching, and then WAN, and then IPv6. At the end of that 5 day, you will able to complete all the topics. Any confusion in that?
No, that's understand. I was just making sure we weren't supposed to be following along. Question for Kirk. When you said you downloaded the ebook, I've got the accelerated student guide open, but mine web-based. So how do I avoid that? Because it keeps timing out on me and then it locks up and I have to re-log in every time.
That we have to see. You should not receive this thing.
I'm not seeing it like Kirk is showing it right now. I'm seeing it as a
Maybe there is a issue with the browser.
No, Daniel. So I had to follow. There's a link when you're on the web version, when you're logged into the Cisco, where you can download the e-reader. And when you download the e-reader, you'll open it and log into the e-reader, and it'll have those two books in the e-reader.
Well, so yeah, I clicked on the content, my content, and then it comes up as my content, and it gives me the two versions. I don't see where.
No, right. That's when you're doing the my content. Hang on one second.
You just log in once again, click and show where is that e-reader software.
Daniel, are you seeing my screen?
I think so.
Okay, so in that email that you got this morning, that was the activation for the Cisco thing.
Yep.
After you go in and log into cisco.com and get your username and password, go back to that email, and then it has the Cisco Learning Network Space link.
Yep, I click that.
Okay.
And then it comes up, and then I have to click on my content, and then I get the two options for.
Right, but see on this page on the network space, if you go to download application and then get it for Windows, it'll download the exe installer.
Okay, so that would have had to be in my downloads.
And then it'll but when you click on that get the application link,
Okay.
when you click to download it, it's going to give you a different username to use for the e-reader, but it'll be the same password for the Cisco site.
Hang on, I'm downloading the e-reader now.
Yes, Daniel, everything is working fine now.
Yeah, I'm getting there. I just opened up the Cisco e-reader. I'm trying to get logged in. So Kirk, was this the email that this is the stuff we set up, right?
Say that again, I'm sorry.
The username and password is the one that we set up?
No, so for the e-reader, when you click the download link, they should have given you another username. But it'll be the same password as the Cisco.
Okay. Yeah, I didn't get an option to set up a new username and password. I got the Cisco e-reader up. It's a blue window. It's asking me for a username and password. What username and password is it?
Yeah, so the username, when you clicked on the download link, that should have had on that page the username that you're supposed to use. It would have been like, it should have been first name, last name, and then 4 numbers. That's what mine was. And then the password is the same password as your cisco.com.
Oh, okay. Well, it didn't give it to me, but I see it in the upper right-hand corner where I click my content now. Let's see if that's it. Okay, that worked. Let's see, student guide. All right, sorry guys, we're good. I'm up. I've got the guide open. That's a lot better.
Okay. So let's move the topic.
I'm back to looking at y'all's screen.
Are you able to see my screen now?
Yes,
I see
sir.
it.
Okay. LAN, local area network. So LAN is networking at a small geographical place, maybe in a campus, maybe in a building, maybe in a room. So if we define LAN, so LAN will be like this. Let's assume these are the PCs. And they are connecting with a switch. So this is an example of a LAN. So normally LAN will be 0 to 5 kilometer in diameter. If we connect like this way, so maybe this is the room 1 and these are the devices into the room 2. This is switch number 2.
When you say 0 to 5 kilometers, is that how far away they are?
Yes.
Okay.
So normally it depends what kind of network devices you are using and what kind of cable you are using between the devices. So let's say if you are using normal layer 2 switches, then we have to use UTP cable, and the length of UTP cable will be max 100 meter. After 100 meter, you have to attach or you have to connect one more switch. So it's like switch to switch, switch to switch, switch to switch, like this type of connectivity. So normally when we are talking about LAN, in LAN we are disconnecting layer 1 and layer 2 devices. So if I'm talking about layer 1, so layer 1 is my PC, servers, or you can say your NIC card, network interface card. When we are talking about layer 2, so in layer 2, we have switches. So if we have to connect all the PCs within a room, then we need just a switch or a hub. So LAN is a local area network to connect devices within a room, within a campus, within a building. MAN. MAN is Metropolitan Area Network. So when we are discussing MAN, sorry, connecting two or more LAN within a city. So normally when we are talking about within a city, so 5 to 60 kilometer or 70 kilometers. So let's assume we have this branch. So this is LAN 1. Let's say LAN 2. Let's assume the distance is 60 kilometers. So tell me, what are the possible solution to connect these two branches?
Fiber,
Okay, first thing is fiber. Yes,
cloud,
fiber, cloud.
I guess wirelessly.
We have wireless option also. We have VPN. Okay, let me discuss one by one. So first thing is wireless. Yes, we can connect with the wireless, but the cost will increase. On every 10 meter, we have to put a access point. And to manage those access point, we have to put the wireless controller. And all the devices will be in open environment. Anyone can easily hack my network at that time. So wireless is not a good solution. We can connect with the wireless, but it's not a good solution. It's not a scalable. Next option is, let's say, fiber. So when we are talking about fiber, fiber means I can write fiber as a ISDN line. Now ISDN line is a permanent connectivity from LAN 1 to LAN 2. So there will be a dedicated connectivity from one branch to another branch. That will be the good solution, but the cost will increase and it's not scalable. Scalable in the sense ISDN line and fiber is point-to-point connectivity. If your sites are increasing, to connect every site you need a separate ISDN line, separate fiber connectivity. So ISDN line is the good solution, fiber is a good solution, but the cost will increase. So normally we are using ISDN line or fiber as a backup connectivity. Next, we can connect with the help of ISP. So we'll connect with the ISP and we'll tell to the ISP to implement certain technology. For example, frame relay, MPLS, VPN. So in that case, from your network to ISP network, that will be the physical connectivity. This will be the physical connectivity, and inside this cloud, that will be the logical connectivity which is maintained by the ISP with the help of certain technology. For example, like frame relay, it's a layer 2 VPN. MPLS, layer 2.5 VPN. We have lots of technology. We can implement the GRE tunnel also. So all these MPLS, GRE, site-to-site VPN, remote access connectivity, all these are maintained with the help of ISP, Internet Service Provider. Same way, cloud, we have to take help from the service provider. So MAN is connecting 2 or more LAN within a city. The length will be 5 to 50 or 60. Next is WAN. To connect 2 or more site across the world. So let us assume this branch is in one country, this branch is in one country. If you want to connect these two branches in different countries, then again you have to take help from the service provider. And again here you have to implement certain technology, for example like MPLS, site-to-site VPN. So whenever we talk about MAN and WAN, in MAN and WAN, yes.
I'm sorry, I don't mean to interrupt you, but it looks like they're having a lot of conversations about us on this course material. Do you need to let them know that you've given it to us, or is there something that we're still missing? Because there is a email chain going back and forth right now of them saying that they should interrupt us. The team between Faraz and Bahram.
You are receiving any email from?
From Faraz Alvi and Bahram asking, one, if we received it, and Faraz is saying they have not received it, and he strongly recommends that he call us both and interrupt the class so that we can have the courseware.
So you have the courseware right now, right?
I believe so, unless there's something that...
No. So they are just verifying, have you received the courseware or not? That's it. Okay.
All right,
So
I'll
you can reply on.
So is the courseware just the two PDFs and the
Yes.
links to the labs?
To the labs?
Right.
Okay. All right.
So you just reply on that mail, you receive the courseware and the lab access.
All right. Sorry, I didn't mean to interrupt you. I just wanted to make sure we have everything and that they're on the same page.
Not an issue. Okay. So whenever we talk about WAN, so in WAN, layer 1, layer 2, and layer 3 devices will use. When we talk about layer 1, your PC, servers, layer 2, switches, and layer 3, routers. So how they will connect, that part we have to discuss. Okay. After that, any idea about OSI reference model? Yes, anyone? Craig, Daniel, what is OSI reference model?
No clue.
Okay. So OSI reference model is a study model. So this model describes how my data is processing into the network. This OSI reference model consists 7 layers. Application, presentation, session, transport, network, data link, and physical layer. So if I'm talking about layer 1, so layer 1 is physical layer, layer 2 data link layer, layer 3 network, 4, 5, 6, and 7. It always start bottom to top. Now, let's assume you are working in an application notepad. And in that notepad, you are writing something. So till the point you are interacting with the notepad application and you are writing something. So you are creating the data. So an application layer is responsible for creating and receiving the data. User always interact with application layer. For example, you are working on some application, you are taking remote access of any device, let's say telnet, SSH, RDP. So we are interacting certain application to access the devices. So that means we are interacting on the application layer. So whenever we are working on any application, let's say Notepad, PowerPoint, so we are creating the data. Clear this thing? Any confusion?
No, that's clear.
Okay, just a second. Okay, Daniel, have you replied on that mail? This courseware.
Yeah, he just thanked me for responding. We're good.
Okay, so I just verify. They are just verifying with me, like, okay, they have received or not. They are calling me. Okay, not an
Yeah,
issue.
we're good.
Okay. So application layer is responsible for creating and receiving the data. So if you are a sender, in that case, you are creating the data. If you are the receiver, then you are receiving the data. Now, presentation layer. Now, once you create the data on the notepad, after that you are saving that thing, right? So once you save, then you are putting some extension. It can be .txt, it can be a doc, can be a exe file. So that adding the format to the data is working on presentation layer. So presentation layer is responsible how data represent in front of user. So that means data format adds on this layer. So data format, example, like .txt, .jpg, .exe. The next layer is session layer. Session layer is responsible for creating and receiving data. Creating and receiving, sorry. creating and terminating session. Terminating sessions. Data communication modes work here. So data communication mode means simplex, half duplex, and full duplex. Now, any idea about simplex? What is simplex process? In simplex process, data travels source to destination, but from the destination we are not receiving any acknowledgement. Any example of that?
Do you mean one-way communication?
Yes, one-way communication, but we are not receiving any acknowledgement. Any example? Okay, example is you are changing the temperature of AC with the remote. So whenever we are pressing the button, the data travel from source to destination. Source is my remote, destination is my AC, right? But AC is not giving me any acknowledgement. The task is done, but we are not getting any acknowledgement. We are changing the channel, TV channels. So these are the simplex process. One-way process, but we are not receiving any acknowledgement. Half duplex. At the same time, only one process will work. Either you can send the data or you can receive the data at a time. If both the tasks happen on the same time, then the quality of data will be not good. For example, walkie-talkie. Whenever we talk with the walkie-talkie, firstly only one person will talk. He gives the acknowledgement, and then
Are you drawing stuff right now?
sorry?
Are you still drawing stuff right now?
No.
Oh.
Clear this thing? Next is the full duplex. In the full duplex, both the process will work at the same time. For example, your mobile phones. Any confusion in that? So it's one-way communication, but no acknowledgement. At the same time, only one process. Sending,
Syntheses.
right. Full duplex, both process works together. Clear the working of first three layer. Application layer is responsible for creating and receiving the data. Presentation layer is responsible how the data will represent in front of the user, means the data format adds on this layer. Once the data format is added, then session layer will add the session on which mode the data will travel source to destination. It is going either in the simplex mode, half duplex mode, or full duplex mode. These first three layers are known as upper layer. Clear? Any question till now?
These little PNG files, are you going to send those to us?
Yeah. At the end of the day, I will share all these screenshot.
Okay. All right. I just was making sure I didn't need to be taking notes.
Okay. No, I will share all these screenshots. Okay. Next layer is transport layer.
Hey, Daniel, just so you know, this is on page 22 in the student book.
Yeah, I'm looking at it. His explanation is a little more layman's terms than the actual book.
Whatever topics I'm discussing, everything will be in the book, but not on the correct order. Maybe some topics you will get on the first page and some topic you will get on the 50 or 60th page. Okay.
Yeah, that's why I was asking if you're going to send them out so that we can get them in the order that you're doing them in.
So you want to go with the books, like whatever topics into the books?
No. I want to follow the way you're doing it. I'm just want to make sure I have something I can reference back to, and the book is way out of what you said.
That I will tell you, like, okay, which topic you have to read at the end of the day. I will do like, okay, this topic is on this page, this topic is on this page. That I will tell you, not an issue. Okay, transport layer is responsible for end-to-end logical connectivity. End-to-end logical connectivity means, let's say you are making a telnet session, right? So telnet work on port number. Any idea? Telnet SSH work on which port number? Telnet work on port number 23. SSH work on port number 22. So whenever we initiate the telnet session, then the ports will open. Port means whenever you run the command like telnet and the destination IP, the port number 23 open, it initiate the session. Okay, so transport layer is responsible for end-to-end logical connectivity. Port number works here. Every protocol is having a predefined port numbers. For example, like HTTP, we have port number 80. HTTPS port number 443. SMTP 25. Now, error checking and error correction occurs on this layer. Next, TCP and UDP protocol work here. Data converted into segment. Acknowledgement, sequencing of the data, segmentation works here. Now, what is segmentation? Let us assume you make a 10 MB data and you are sending the data from PCA to PCB. These are the two systems, PCA, PCB. And from here to here, you are sending, let us assume, 10 MB data. Now tell me one thing, when you are attaching a file, you are sending via Gmail, Yahoo, or any method. So the data will go into a single packet 10 MB, or the data will break up. Yes, data will travel into a single packet, single 10 MB packet, or what? Daniel, Crick, any idea about that?
I'm sorry, can you say that part again?
Let's say you are sending a 10 MB data from your system to anyone. The data size is 10 MB. So I'm just asking that 10 MB data will travel into a single packet or into the multiple packet?
It should be multiple packets.
Yes. So your data will be internally break up automatically, and that is known as segmentation. And who is doing that segmentation? Your operating system. Why? Because every port is having a predefined MTU size. There is a MTU, maximum transmission unit, means how much maximum amount of data you can transfer through a particular port, and the default size is 1500 byte. Means maximum data size can be 1500 byte. You can increase and decrease that data, but by default the size of MTU is 1500 on every port. I will show you that thing when we'll do the labs. Clear this thing? Any question? Okay. TCP and UDP protocol work here. TCP is transmission control protocol, UDP is user datagram protocol. These are the two categories of the protocol under which we have lots of protocol. For example, like if we have TCP, in TCP, Telnet, SSH, HTTP, SMTP, POP, ICMP, all these protocol will come under the TCP category. Means the protocol who is giving acknowledgement, that will come under the TCP. Let me give you an example. You are doing ping and then destination IP address, right? After that you are getting reply from. So what is that reply from? That reply is basically acknowledgement. You are able to communicate with that PC. If you are unable to communicate, in that case you are getting request timeout or destination host unreachable. Again, those are the acknowledgement. In UDP you will not get any acknowledgement. For example, DHCP process. In the DHCP, your system is requesting for the IP address. DHCP is sending offer packet, and you are receiving the IP address, but you are not getting any acknowledgement. Any question? Next is network layer. Network layer is responsible for best path selection. IP protocol work here. IP address works here. Segment converted into packets. Routing security functionality work here. Router work here. So network layer is responsible for best route selection. So let's say you are going to communicate between the two sites. So in that case, I want to communicate here to here. So in that case, what will happen? The traffic firstly comes to the router. Router will check the routing table. In that routing table, it will get, I have two paths. One path is via ISP1 and one path is via ISP2. So it will calculate the metric based on the routing protocol, whatever routing protocol you configured. So based on that, it will identify which route is the best route to reach this destination. So let's say if it find ISP1 is the best path, so the traffic will move to ISP1. If it find ISP2 is having the best path, so the traffic will move to the ISP2. Which is the best path, that depend what kind of protocol you are using on the router. Every protocol is having the different characteristics to select the best path.
Does it do that every time, or does once it's found that path, does it use the same path?
No. Once it will calculate the best path, until there is no change, the path will be same. For example, here I use any protocol, for example, like RIP, any protocol, and it find out this is the best path. But I have two paths, this is the best path. So in my routing table, both path will be there. Path 1 and 2, both path will be there in my routing table, but in the routing table, there is information, this is my best path. So the traffic will move via the best path. In any situation, if this link goes down, so the traffic will automatically shift over to the ISP number 2. Clear this thing? That is the property of routing protocol basically.
Can you give me two examples, like an example of what would make it a good path rather than a bad path if it was not up or down? Is there anything outside of being physically down that would make it a bad path?
Okay, let me explain more.
I mean, I understand if it's completely not working, but what would make it a bad path?
Okay, not an issue.
I guess the question I have is, are you creating the router table and defining what is the best path to begin with?
Right,
Yeah,
right.
or is it automatically finding that?
We have to discuss all this stuff, but on the second day.
Oh, okay.
but not a issue. Let me explain.
So we're getting ahead of ourselves a little bit here.
Let's say we have this scenario. This is my LAN 1 and LAN 2. Okay. Here, let's assume we have network 10. And here, let's say we have 20. I want to communicate from here to here. So when the traffic, and let's assume on every router, there is a protocol RIP, routing information protocol. This is the dynamic routing protocol. We'll discuss this thing. So RIP is working based on the number of hop count. Number of hop count means how many routers are there between source to destination. So it will just calculate how many routers are there between source to destination. It doesn't count any bandwidth, any delay, nothing. It will just see how many routers are there between source to destination. Okay. So if you see 1, 2, 3. So if it is choosing this, if it is going this upper path, here the hop counts are 3. If it is choosing this path, lower path, so hop count are 4. Right? Lower the hop count, route will be more reliable. So this R1 will build a routing table. In that routing table, it will put all the routes, and it will check when this PC is sending any traffic, the traffic is coming to this router. Router will check this routing table. In that routing table, it will get both the path, but it will see I have this destination 20 via hop count 3 and via hop count 4. So lower the hop count, route will be more reliable. So my traffic will move like this way. In any situation, maybe this link goes down, maybe the cable is not working fine, maybe this router is not working fine, maybe the route on R2, the RIP protocol is not working fine. So that route will be not the best path. In that case, what will happen? That will be the unreachable, and this path will be automatically active at that time. Clear now? Any question here? Daniel, Craig?
No, I think I understand.
Okay. We have to do this lab. Okay. So we'll do all kind of scenarios. Backup route, primary route, everything will be there. Next. Data link. Data link layer is responsible for interaction between physical layer and network layer. This layer is divided into two sub-layers. One is known as LLC and MAC. LLC is logical link control. Who is maintaining this functionality? MAC is media access control. It handle MAC address. Next. Error checking works here. Packet converted into frame. Switches works here. Last is physical layer. Physical layer is responsible for end-to-end physical connectivity. Data, or you can say frame, converted into bits and bytes. Means binary form, like this way. Hub, PC, server, NIC card work here. So if I summarize all these layers, application, application, presentation, and session layer, they are creating the data. So let's say this is my data, a big amount of data. When the data reach to the transport layer, on that transport layer, this data break up into the segment. Then segmentation works here. So segmentation means this data is break up into the small pieces. This one piece is known as segment. When the data reach to the network layer, it convert into the packet. So packet is a collection of segments. Frame. So this is the frame. And when the data reach to the physical layer, bits and bytes, means everything will convert into the 0 and 1 form. On this layer, port number add. Port number means whatever services you are using for exchanging the data. On network layer, IP address attach. Here, MAC address. And the physical layer is a transport medium basically through which my data is traveling. Clear this thing? Any question here? Okay. Let's take an example. Whenever you are sending letter to anyone, what are the information on that letter? Anyone? There will be a data, whatever you have written inside the letter. Then there is a address, and there is a zip code. What is the use of zip code?
Are you asking what a zip code is used for?
Yes.
So the data knows where to go.
Right. So that zip code is a unique code, right? For every place. So you can simulate this zip code is your MAC address. MAC address is a unique address on every system. IP address. IP address is like your address. It can be whatever address you are writing on that letter, maybe the same address present on any other country. Sorry. But zip code will not be same, correct?
I'm a little confused. It seems to me like wouldn't the zip code be more the IP address, or is
No.
isn't the MAC address more specific?
No. I'm just comparing the like let's say you are sending any letter to anyone. So I'm just
or maybe I'm just digging down too far into the weeds on that.
Right. So MAC address is the permanent address of every data. That MAC address is present on your NIC card and NIC card. And that is a hardware address. IP address is a logical address. The same IP address can be exist in different company in different branch. For example, on your system, you are using a IP address 10.0.0.10. I can use the 10 network in my network. It will not create any issue. But same IP cannot be present in same premises. If I'm working in your company, in that case, you are using 10.0.0.10 and again I'm using 10.0.0.10, then we will get a message duplicate IP address exists, right?
Right.
So address can be same, but MAC address can't be same. We'll discuss this thing in detail. Okay. This whatever property I discussed in OSI reference model, you will get 2 questions in your exam. And those 2 questions will be based on the properties. Clear this thing? Question can be basic, simple question. Maybe they can ask, what is the PDU? PDU. PDU is protocol data unit. So the question will be like this: what is the PDU of the transport layer? So PDU means what will be the logical conversion of the data on that particular layer. So PDU of application, presentation and session layer is data. Transport PDU is segment. Network, packet and data link frame. Any confusion here?
No, that makes sense.
So this is the OSI reference model. It's just a study model. The actual data is not traveling through this model. Actual data is traveling through the TCP/IP model. So next we are going to discuss TCP/IP model. TCP/IP model consists 4 layers. It's a practical model. Actual model through which my data is traveling. So here the first layer is application, host to host layer or transport layer, network interface layer, so internetwork, and this is network interface layer. Now application layer, same way, creating and receiving data, host to host layer, provide logical connectivity, internetwork layer, provide the best path, and network interface, provide physical connectivity. So if you see this model, I am unable to explain the complete process, how my data is traveling from source to destination. So just to describe that process, they make the OSI reference model. So remember one thing, my data actually traveling through the TCP/IP model, but on the TCP/IP model, I am unable to explain the complete process, how my data is traveling into the network. So just to explain that process, they developed a new model which is known as OSI reference model. So OSI reference model is just for the study purpose, how my data is traveling into the network. Means firstly data will create, then segmentation will happen, then packet, then frame, and then the data is converted into bits and bytes, and after that it is traveling to the destination. Clear this thing? OSI is study model, reference model, and TCP/IP is practical model, physical model. OSI is developed by ISO, International Standardization for Organization, whereas TCP/IP developed by DoD, Department of Defense. let's take a 5-minute break and then we'll continue. Okay. Any question?
No,
Daniel,
sounds good.
okay, one more thing. Whenever you need a break, then let me know, because like normally I will take break whenever the topic is complete. So in between, if you need a break, then let me know. Okay.
Understood.
Okay. We'll meet after 5 minutes. Okay, I'm back. Crick, are you there? Daniel?
This is Kirk. I'm here.
Okay. Next topic is encapsulation and de-encapsulation. Now, encapsulation means adding some protection to the data. So whenever data travel to any kind of link, maybe the link is Ethernet link, maybe the link is serial link, maybe the link is the fiber link, maybe the data is traveling on the tunnel. Every kind of medium will put their own kind of encapsulation. Sorry. So encapsulation means wrapping of your data. So whenever my data travels source to destination, so for example, this is A, B. A is sender, B is receiver. Application. Okay. So let us assume A is my sender and B is receiver. So application layer create the data. So this layer create the data. So on this layer my data is created. So when this data comes to the presentation layer will not accept the data until the data is not authenticated. So just for authentication, this application layer put a header, and that header contain that information, this data is verified. So it put a, let's say AH is a application layer header, and after that we have data. So same thing happen on the session layer also require authentication. So presentation layer put PH, AH, and then data. So in the same way, every layer require the authentication. So on the data link layer, you will get headers plus the data. On physical layer, everything is converted into 0-1 binary form. Physical layer provide the physical connectivity. So when this data received on PCB, so on physical layer, everything will be on binary form. When it reach to the data link layer here, then it will get headers and data. But if you see, we sent only data, and headers are the extra amount of data. which is not required here. So on sender, these headers, these are my header. This is the extra amount of data which is attaching to my data. So this process is here known as encapsulation, means wrapping of your data. But this wrapping of the data is the unnecessary data on the receiver side. So on receiver side, Taylor add. Taylor is for de-encapsulation, means when the data received by data link layer to the network layer, it will add DT. DT is data link Taylor, and there will be a DH also, data link header. So it will neutralize that thing. Then network layer header, it will attach NT, network layer Taylor. So it will neutralize. So in the same way, all the header will be neutralized by the Taylor, and on the application layer, you will just receive the data. Just removing these header information from the Taylor, this process is known as de-encapsulation. Clear this thing? So every time whenever you are sending data from source A to source B, encapsulation and de-encapsulation occurs. Based on that, what kind of connectivity you are using? You are using Ethernet connectivity, serial connectivity, you are connecting through the tunnels. Based on that, encapsulation and de-encapsulation works. Clear this thing? Any question here? Next, cable. Cable is a transmission media through which data travel. So basically, cable is three type: coaxial cable, twisted pair, and fiber. In coaxial, we have 10 base 2, 10 base 5. In twisted pair, we have two type of category. One is UTP and STP. With the help of UTP and STP, we are creating a straight cable, cross, rollover. In fiber optic, we have two types: single mode, multi-mode. Ten base 2 is known as thin net cable, and this is known as thick net. coaxial cable. Used as a backbone cable in bus and ring topology. What is bus and ring topology? That we'll discuss in next topic. Coaxial cable is two type. 10 base 2. 10 base 2 means 10 Mbps speed, baseband signal, till 200 meter. This 200 meter is approximate, actual value is 185 meter. Ten base 5, 10 Mbps speed, baseband signal till 500 meter. Right now we are not using coaxial cable as a networking cable because of the speed. Right now we are discussing about like 100 gig speed in the new devices. If you have data center switches, then we can support till 100 gig speed. So this coaxial cable is just providing me 10 Mbps speed. So this is not used into the network. Right now coaxial cable is just used into the cable networks. Next is twisted pair. Twisted pair. In twisted pair, there are 4 pair, 8 cables, which are twisted with each other. It will be like this. Let's say this is the outer cover. In that outer cover, cable are twisted like this way. Like this way. So the major color will be orange, green, brown, and blue. So these will be major 4 colors, and one cable will be like orange white, green white, brown white, blue white. Okay. Now there is a question. In this outer cover, I am putting 8 cables and I'm twisting those cables. Is there any benefit we are getting for twisting the cable? Anyone?
I'm assuming it's thinner.
Sorry?
I'm assuming it's thinner because you're twisting it.
Yes. We can put 8 cable, straight cable inside this outer cover, right? Why we are doing extra task, twisting the cable? We are getting any benefit for that?
Saving space.
No, space will be same. Okay.
Stronger.
No.
You're creating more resistance on the cables by having more twisted into a smaller area.
No, actually the thing is, there is a physics concept. The concept is like this way. If your current is traveling in this direction, here current means our data, because our data is traveling in the form of signal. Signal is current, right? If the data current is traveling in this way, in the perpendicular direction, the magnetic field generate automatically. And it's a natural phenomena. So my data is traveling like this way. So this magnetic field will try to attract my signals, and some amount of signal will go outside my cable. So when the signal will go outside the cable, then data loss. Clear? So it will happen if I am putting these straight cables. So if we are putting straight cables, in that case, there is a chance of data loss. When we twist the cable, the point where the cable cross each other, the magnetic field will be 0. So the magnetic field is generating, terminating, generating, terminating. It is not continuous. So the chances of the data loss will be reduced. Okay. So why we twist the cable? Just to reduce this magnetic field. This thing is known as EMI. Electromagnetic interference. So the question is, why we are twisting the cable? So the answer is just to reduce the EMI, electromagnetic interference. Clear this thing? Now, in twisted pair, we had two category. One is UTP and STP. UTP and STP. UTP is unshielded twisted pair. STP is shielded twisted pair. So UTP is like that. Firstly, you will get a outer cover, plastic outer cover. Inside that, you will get 8 cables, 4 pair cables. That is the UTP. STP cable is same, but the difference is, firstly you will get outer cover. Under that outer cover, you will get a aluminium foil. That foil is for, let's say, for any reason. If after twisting also the signals are trying to go outside the cable, so it will reflect from aluminium foil and it will stay into the cable. So there will be no data loss in STP. Now, next question is where we have to use UTP and STP. UTP cable you can use inside the network internally. STP cable we are using in that case where some amount of cable will be on the open environment. STP cable is stronger than UTP because of the aluminium foil. So there will be less effect of the environment on that STP cable, like sunlight and rain. So STP cable we are using in the open environment and UTP we are using inside the campus. But functionality wise, UTP and STP cables are same. Now, UTP and STP twisted cable are base cables. With the help of UTP and STP, you are making a straight cable, cross cable, rollover cable. Straight cable is used to connect different devices. For example, PC to switch, router to switch. Cross cable used to connect same type of devices. For example, like PC to PC, switch to switch, router to router. Router to PC, exceptional case. Rollover used to access console of the device. But right now we are not using this rollover cable into the production environment. We are using, instead of rollover cable, we are using console cables. So rollover cable and console cable are same. Console cable is the branded cable which you can get from the market. Rollover cable you have to make. So this is the straight cable color coding. So if on the both the side, if you put the same kind of color coding, the cable will be straight, and the standard is known as 568B. So for example, on connector 1, I connect cable like in this order. First cable is orange white, then orange, then green, blue, blue plus white, green, brown, brown white. If the color coding is same on another connector, connector number B, then the cable will become straight. In cross, there is a rule. The rule is 1 2 3 6 3 6 1 2. Means firstly you have to make a connector number 1. So once the connector A is ready, then you have to follow one rule. Whatever cable is on first number on the connector number 1, connector number A, that will comes to the third number. The cable which is on third number, that will go to the first number. The cable which is on hold on. No, there is something. It's like this way. Straight cable. Let's see. Connector A. Connector B. So 1. So let's say first cable is orange, orange plus white, blue, blue plus white, brown, brown plus white, green, green plus white. You can take any order on the connector number 1. If on the connector number 2, you are making the same color coding, so cable will become straight. For the cross, cable there is a rule 1 2 3 6 3 6 1 2. Means let's say you make connector number A. Connector number 2 you have to make via this rule. So whatever cable is on first number on the connector number A, that first cable will be on third number on the connector number B. So first is orange. So orange will be on the third number. The cable which is on second number, that will come to the sixth, means orange white. The cable which is on third number, that will come to the first, blue. The cable which is on the sixth number, that will come to the second, blue white. Sorry, brown white. And rest color coding will be same.
So it's only those 4 that are switched, the rest all stay the same?
Right.
Okay.
One more thing, my data is traveling through only these color coding, means for sending the data only these cables will be used. But why we are using those 8 cables in that case? What is the use of next 4 cables? Anyone?
For the header information?
No. Are you using Cisco IP phone?
Yes, we are.
Then how you are providing power to the IP phone?
Oh, it's PoE.
Exactly. So next 4 cables, rest of the 4 cables are providing you the power. Clear now?
So the 12363612 is for data,
Right.
and 4, 5, 6. Wait, 4, 5, 7, and 8 are power.
Yes.
For a cross cable.
No, in straight cross rollover, same.
Oh, okay.
Clear this thing?
Is it really 9 o'clock at night where you're at?
My time is different.
I understand. Is it 9 o'clock where you're at?
On my side,
Yes.
yes.
Oh, wow. Hats off to
So next is rollover cable. So rollover cable is just used to access the console of the device. You cannot send any data through console cable or rollover cable. So it's like this way. Connector A, let's say you configure orange, white. Connector 2 will be just opposite. Means whatever cable is on 8 number, that will be on first. That will be your rollover cable. Clear this thing? Right now, no one is using rollover cable. Everyone is using the console cable, which is the branded cable, which is available into the market. Then we have UTP categories. In UTP, we have Cat1, Cat2, Cat3, Cat4, Cat5, Cat5e, Cat6. Okay. So normally into the production environment, we are using Cat5e or Cat6 cable. So if you have Cat1, you will get 1 Mbps speed. So normally we are using this thing into the telephone network. In Cat2, we are getting 4 Mbps speed. We are using this thing into the token ring topology. Cat3, we are using 10 Mbps speed into the Ethernet network. Cat4, 16 to 20 Mbps again into the token ring. In Cat5, we are getting 100 Mbps speed. And this is only for data. And Cat5 is known as fast Ethernet. In Cat5e, 102,000 Mbps. And Cat5e is used for data and voice both. Cat6, 1000 Mbps, known as gigabit Ethernet. So these are the UTP categories.
So are these all backwards compatible then? Can you use Cat 6 in place of Cat 1, or does it have to be?
No, not like that. Because Cat 1 will use RJ11.
Okay, so like Cat 5 up 5 to, or sorry, Cat 3 up to Cat 6 is all RJ45, right?
Cat 1 and Cat 1 is RJ11. After that, they like Cat 2, Cat 3, Cat 4. These cable having the separate connector, BNC connector. Cat 5, 6, Cat 5, 5E, Cat 6. These are using RJ45 connector.
Okay, so you said 2, 3, and 4 are using BNC?
Right.
Okay.
Then we have fiber optic. In fiber optic cable, we are getting high speed, and in fiber optic, the data source will be light. High speed and data source will be light source. In this, we have two category. One is the single mode used to send data for long distances. Then we have multi-mode to send data on short distance. Okay, short distance means, let us assume in my data center I have two core switches and I want to connect those two core switches with high speed connectivity. In that case, I will use multi-mode cable. If I'm going to connect two data center directly, which are, let's say, 100 kilometers distance, then I will use single mode cable. Clear this thing? This is all about cables. Next, we have topology. Physical arrangement of network devices in a regular and arranged manner. Types. So basically we have two type of topologies. One is the physical topology, one is the logical topology. Here we have to just discuss about the physical topology. How the logical topology will form, that I will explain into the switching part. So first type is bus topology. Right now no one is using bus topology. So bus topology is like this way. All PCs are connected through the backbone cable. If you see the requirement, This will be the T-type connector, which is connecting the piece of the cable and the PC. So here the requirement are terminator. Terminator are used at the end of the cable just to stop the signal inside the cable. Then T-type connector, which is used to connect the cable and PC. On PC there will be BNC connector on NIC card, and this cable is backbone cable, which is my coaxial cable. So in bus topology, all computers are connected through the backbone cable. Bus topology is easy to implement, but we are not using this topology. The reason is fast speed. In coaxial cable, we are getting only 10 Mbps speed. Second disadvantage, if there is a problem, let's say PC1, 2, 3. If you are sending data PC1 to PC3, then if the data is not received on 3, in that case, you have to check each and every node. So fault tolerance is not easy in bus topology. You have to check each and every node. Where is the problem? Then we have ring topology. In ring topology, all computers are connected through the backbone cable in a closed loop. All computers are connected through the backbone cable in a closed loop. Requirement are same. BNC connector on PC, T-type connector, and third one is backbone cable. Now, let us assume 1, 2, 3, 4, 5. You are communicating 1 to 5. In ring topology, data always travel unidirectional. Clockwise. Means if PC1 is sending data to PC5, so data will not go like this way. No. Firstly, data will travel to 2, 3, 4, 5. If there is a problem anywhere between 1 to 5, data will not travel. So if any PC goes down, PC 1 to 5, there will be no communication. Then we have third topology, star. In star topology, all computers are connected with each other with a centralized device.
I'm sorry, I have a question on the ring topology.
Right.
I know if it's down, does that mean if it's off as well? Meaning that 2, 3, 4 would have to stay on for the communication from 1 to 5?
Right.
Okay. All right.
In star topology, all computers are connected through a centralized device, hub or switch. Like this way. So if you go with the requirement, so requirement is UTP cables. UTP cable depend on the device connectivity. For example, here we are connecting PC to switch. In that case, the cable will be straight. Then RJ45 connector on both PC as well as on NIC card. Then switches. Now, in this star topology, if one PC goes down, then there will be no effect on the entire topology. But if the centralized device goes down, the whole network will be down. Clear this thing? So right now, everywhere is you will get a star. Next one is hybrid. Hybrid is basically intermixing of two or more topologies. For example,
Is that what they call in the handbook a mesh topology?
MASH we'll discuss next.
Oh, okay. So you're talking about one.
So this is my star topology. This is star. If I connect these two switches, bus. So this type of network is known as hybrid network. A star topology is connecting with the help of bus topology. Okay, and it's not mandatory. Any kind of topology you can connect. Again, it is based on the devices, what kind of devices we are using. And last one is MASH. MASH topology. In MASH topology, all computers are connected with each other with multiple physical links. So they are directly connected with each other with multiple physical links. Like this way. MASH topology, again, we are not using this topology. The reason is just to connect these 4 devices, I'm using 8-9 cables. So your cost will increase, your network will be complex. Only one benefit you are getting here, the benefit will be redundancy. Redundancy means, let's say you are communicating 1 to 4. So you have this path, you have this path, you have total 4 paths. Either you can go via 1, 2, then 4. You can go directly 1 to 4. You can go 1, 3, 4. Or you can go to like this way 1, 3, 2, and then 4. So you have multiple paths in that case. But cost will be increase and network will complex. Here we have only 4 PC, but let's assume you in your network you have 10 PC and you are implementing MASH topology. We cannot do that thing because we have limited slots into the PC. You can attach maximum 3 to 4 NIC card only. Clear this thing? This is your cables. Next, we have network devices. So in the network, we have lots of devices. For example, we have router, switches, firewall, load balancer, access point, WLC, wireless LAN controller. We have hub. So we have all these devices, but we have to discuss only router, switch, and hub here. Okay. So I will discuss like what are the differences between hub, switch, and router. Now, let's discuss a brief introduction about firewall. Firewall is basically a working as a wall between your private network and the external network. So you can define the rules on the firewall. Okay, only this kind of traffic is allowed. Only this user is able to access internet. Only this particular site is allowed. So if you want to do this kind of filtering, then you have to use firewall. Load balancer is used, let's say in your organization you have two servers. Every time your internal user are trying to communicate with the server 1. So if the server 1 is getting a lots of requests and the server is not capable to resolve all the queries at the same time, so maybe the server will hang. So just to reduce the load, we are using load balancer. So load balancer are intelligent device. They will identify, okay, on that particular server the load is very high, so let's distribute some traffic to the another server. Access point, wireless access point are used to connect the wireless devices, for example like your laptop, your mobile phones. WLC, wireless LAN controller, is used basically if you have multiple access point and if you want to manage all the access point through a central point, then you can use a WLC. In that WLC you have to add all the LAN access point, and once you register the access point on the wireless LAN controller, you can manage all the access point through a central point. Hub. Hub is a layer 1 device. Layer 1 device means it work on the physical layer. Hub. Can't understand. IP address and MAC address. Hub doesn't have any memory. Every time flood traffic. Work on half duplex. Hub create a single broadcast domain and single collision domain. Hub divide the bandwidth. Hub divide the bandwidth means, let's say on the hub there are 4 ports and there is a uplink. Through that uplink you are getting the 10 Mbps speed. So hub will divide 2.5, 2.5, 2.5 Mbps on each and every port. So it will divide the bandwidth. Hub doesn't have any memory. It is not creating any MAC table or routing table. That's why every time it will flood the traffic. Hub cannot understand IP address and MAC address. It work on half duplex. These are the properties on hub. Then switch. Now switch is layer 2 device. We have layer 3 switch also. We'll discuss those things. What are the difference between layer 2 and layer 3 and how to identify those things. Switch have memory. It create MAC table. Switch can understand MAC address. Switch forward traffic based on MAC table. If there is information of destination MAC, in MAC table, then traffic is unicast, otherwise traffic forward to all ports, which is known as unknown unicast. Switch work on full duplex. But if you want to modify, let's say half duplex, auto, you can modify those things. Doesn't share bandwidth. Switch create a single broadcast domain and multiple collision domain. These are the properties of switch. Then we have router. Layer 3 device. Router have memory. Store routing table. Can understand IP address. Work on by default unicast. By default, router work on unicast. If any broadcast and multicast packet comes to the router, simply dropped. If you want to allow multicast packet, specifically you have to enable the protocol, PIM protocol, which is responsible to forward the multicast traffic.
Sorry, what was that protocol called?
PIM, protocol independent module, PIM protocol for the multicast. In layer 3 we have PIM, and if we have layer 2 network, in that case we have IGMP protocol. A divide broadcast domain. Full duplex. Okay, the duplex setting depend on the hardware model as well as on the iOS model, iOS version. Okay, so maybe if I'm writing here full duplex, by default most of the devices are into the full duplex, but there are some devices which are configured into the auto duplex mode. Okay, that is depend on the hardware model and the iOS model. Understand IP address. It forward traffic based on routing table. Doesn't share the bandwidth. But you can manage. You can manage bandwidth means, let's say if you want to give priority to some traffic, for example, in your network, you have three kind of traffic: video traffic, voice traffic, and normal data traffic. So if you want to give more priority to the video traffic, then you can allocate a particular bandwidth to that traffic. So that thing we are doing with the help of QoS, quality of service. So there is a point here. Hub create a single broadcast domain and single collision domain, and in switch we have switch create a single broadcast domain and multiple collision domain. So first understand what is the broadcast domain and collision domain. Broadcast domain. Now broadcast domain is a type of communication where the sending device send a single copy of data will be delivered to all devices in the network. For example, let us assume all devices are hub. Let's say switch. Let's say if we have this connectivity, if this PC number 1 is sending some traffic to, let us assume, this PC number 2. So what will happen? It will send traffic firstly to the hub. This hub is not having any kind of memory, right? So it doesn't know where I have to forward the packet. So what it will do, it will forward the traffic to every node because of the single broadcast domain. It will forward any kind of traffic to all the ports due to the single broadcast domain. So that traffic will reach to the hub 2. Same thing will happen. Once the traffic reach to the switch, and if the switch is into the default condition means there is only VLAN number 1. What is VLAN? We have to discuss that thing into the switching part. But here I'm just taking an example. On that switch, we have two VLAN, VLAN 1 as well as on VLAN 10. So some PCs are into the VLAN 10 and some are into the VLAN 1. So by default, that traffic will travel only on VLAN 1 because in the switch there is a single broadcast domain. Single broadcast domain means one VLAN. Every VLAN is having one broadcast domain. So that traffic will not go here. This is the example of broadcast domain. And the last one is collision domain. Is a network segment in which collision can happen in Ethernet network if the devices are connected with the hub using a shared media. For example, like bus topology and ring. Okay, so if for example, like let us assume this switch is having these PCs. This switch is a fresh switch. Right now there is no MAC table. I'm trying to communicate PC1 to PC, let's say 6. So what will happen when the traffic comes to the switch? Switch will check, is there any information regarding the destination MAC? If the destination MAC information is available, then the traffic is unicast. Otherwise, traffic will go to the every port. It will receive, it will give reply. So once it will reply, the table will create, MAC address table will create. So once there will be an entry about the destination MAC, and again if PC1 is sending data to PC6, then the traffic will be unicast. Clear? This is my network devices. Next, we have to discuss about IP address. IP address. IP address is numeric identifier of device. IP address is logical address. Logical address means you can change the IP address. IP address have two parts. One is network and another one is host. IP address provided by INA. It's a worldwide organization who is responsible for providing the IP address. INA is International Assigning Number Authority. IP address have two versions. IPv4 and IPv6. So right now I'm just discussing IP version 4. IPv4 is 32-bit long. IPv4 is divided into 4 octet. Each octet have 8 bits. IPv4 is in decimal form. Decimal form means 0 to 9 characters. In IPv4, octet separated by dot. Loopback address is 127.0.0.gist network.
Isn't it .1?
No, the complete network is reserved for loopback testing. Normally we are using .1, 127.0.0.1, but you can try any IP address from this subnet. That particular subnet is just reserved for loopback testing.
Okay.
What is the use of loopback address?
I didn't hear that. I'm sorry.
What is the use of loopback address?
So you can get into the machine, correct? Without an IP address?
Loopback address is used to verify your LAN card is working fine or not. If you are unable to communicate, maybe the reason is your LAN card is faulty. Your LAN card is not working fine. So how we can check? So simply if you ping 127.0.0.1 or any IP address from this subnet, then it will check the physical hardware that is working fine or not. If you are getting reply from, that means your NIC card is working fine. If the NIC card is not working fine, then you will get some error like hardware issue or hardware not found, like that. Next, IPv4 classes. So we have class A, B, C, D, and E. Class A start from 1 to 126. I'm just writing the first octet. 1 to 126 means 1.0.0.0 till 126.0.0.0 octet. Class B 128 to 191. The default subnet mask will be class D and E is not having any subnet mask. Class A, B, and C, these are user specific. User specific in the sense user will get IP address from class A, B, and C. Class D is reserved for multicast. So whenever we are doing multicasting, we are using class D IP address. Class E is reserved for research and development. Military and scientists are using this class IP addresses. So 127 network is used for loopback testing. Subnet mask, this is the default subnet mask. Network and host part, these are the net octet basically. So first octet is reserved for network. So I can write like this way also. Remember one thing, subnet mask always comes from network bit. So /8 means 255. If I'm writing /16 means 255.255.0.0. So these are the total IP addresses 1 to 255. Now,
Sorry, can you explain
any question?
the /8?
Yes, Daniel, Craig, any question?
No, no question.
So I'm just curious, the last part you had on the 8, 16, 24, can you expand on that a little bit more?
Sure. As I told you, IP address is 32-bit, right? So I can write those 32 bits are like this way. Let us assume my address is 10, 0, 0, let's say 10. That is my IP address. So what will be the subnet mask? In the default condition, N, H, H, H. So that means first octet is reserved for network. That means all these bits, first octet bits, are the network bits. And these are the host part. So whenever the IP address change, the network ID will not change. Means this 10 will remain same. The last octet will change. Clear this thing? Let's say it starts from 10.0.0.1, 2, 3, 4, 5, 6 like this way. So only the host part will change. Network part will remain same. And once these bits are network bits, so there is a calculation. I will explain that thing, like how the calculation will work in the next topic, which is the subnetting. If all these bits are used, in that case you will get 255. These bits are not network bits, that's why 0, 0 and 0. So you can remember like this way: if all bits in the octet are used as a network bits, then you will get 255. Clear or need some more clarity?
Well, so how did, I guess I'm still confused how you got that /8. Is it because it's the 8
That is the
bits?
default. See, that this is the default condition. In class A, by default subnet mask is this. Okay, this thing is clear. 255.0.0.
Yes.
This is clear. Okay, you are confusing here 8.
So is
Right?
it because that first part is the network, and so those 8 bits for that first octet, is that where you get that /8?
Right.
And then for the second, or the class B, is the first 2 octets, so that's your 16 bits, and then class C is the 3 octets, and that's 24 bits.
Exactly.
Okay, thank you.
So they're all being used.
Yes.
8, 16, 24. Moving down.
Yes.
Okay.
Okay. After that, we had types. Now in types, IP address types, we have public IP, and private IP. Yes. What are the public IP? Any idea?
No.
Do you have internet in your mobile?
Well, so the public IP is the network facing outward, and private is something inside your subnet, right?
Exactly. So the basic concept is that through the public IP, you can directly access internet. So let's say we on the mobile, we are using the internet service. So we are talking with the service provider. Okay, I just want internet service. So what service provider will do? He will assign you a public IP directly on your phone. That's why you are able to access internet. If you are taking the broadband service from the service provider, in that case, what will happen? Service provider will give you a line till the modem, right? And through the modem, you are connecting your laptop, PC like this. So on the modem, there is a public IP address. And inside the network, you are using the private IP address. So public to private IP address translation is done through the netting process, NAT. And that NAT service is by default enabled in your modem. That's why you are able to access internet in the broadband connectivity. Okay, I will explain this NAT. I will show you the practical part, complete practical part we have. So we'll discuss that netting part. So as a basic properties, public IP addresses, you can directly access internet. Public IP are unique and limited. We have limited public IP addresses in the IPv4. That's why we need a new version, which is IPv6. Private IP address. You can't access internet directly. You need at least one public IP address with NAT. These are unlimited because these are free. You have to pay in public IP address. Okay. Duplicate private IP address. Private IP address, duplicate private IP address can't be used into the same network, but in different networks you can use. For example, in my company, I can use 10.0.0.10. In your company, you can use 10.0.0.10. There will be no problem. But if same IP address we are using into the same organization, then we are getting the error message, duplicate IP address exists. Private IP addresses. So how to differentiate? Okay, this is the public and this is the private. In every class, in class A, 10.0.0.0.0/8. This full octet is reserved for private. In B, 172.16.0.0 till 172.32 31.0.0/12. In class C, 192.168.0.0/16. This is reserved. Reserved for private. And rest of all IPs are public. Apart from these networks, all IP addresses are public. Next, classful network. If an IP have default subnet mask with respect to the class, that IP known as classful. For example, in class A, let's say I have 10.0.0.10. If I'm using the subnet mask, this, it's a classful IP address. Let's say in class C, if I'm using classful, so it's C class and I'm using the C class subnet mask. Classless. If an IP doesn't have same class subnet mask, that IP known as classless network. For example, we have a 10 network IP address, and if I write subnet mask this, IP address is class A, but the subnet mask is not from class A. It's class B subnet mask. So this type of IPs are known as classless. Next. How many ways?
I'm sorry, what is the benefit of knowing if it's a classless or class?
Okay, that is the next topic, subnetting. Okay, but let me tell you, the benefit is security, and it will reduce the wastage of IP address. For example, in your company, how many departments you have? Let's say sales, HR, account. There are lots of departments in every company, right? If my requirement is like this way, I just want to communicate within the sales department. Means sales user will not communicate to the account. Account user will not communicate to the IT team. IT team will not communicate to the finance team in the default condition. So we are making as that network as a classless. Okay. Now, in some situation, we have a requirement. Okay, I want to communicate only these two branches, or let's say these two departments. In that case, manually we can do that task. We can communicate them.
Understood. Thank you. Thank you.
how many ways to assign IP address? How many ways to assign IP address? So first method is static method. So manually you can assign IP address. Second one, DHCP. DHCP is clear or not? Dynamically, automatically you are getting IP address from the DHCP, right?
Correct.
And third option is APIPA, APIPA, automatic private IP addressing. Have you seen this IP address 169.254.255.10? Any means this part can be anything. Have you seen this IP address?
No, I don't think I've come across that. Kirk, have you?
Sorry?
I have not seen that address. I was asking Kirk if he.
No, I haven't.
Okay. So let's assume this is the PC. On that PC, there is no static IP address. You are not defining any IP address manually. Then there is no DHCP. Then this system will automatically take IP address from this range 169. And that IP address is known as APIPA IP addressing. Clear now? I will show you that thing. So this is all about your IPv4 addresses. So next thing is subnetting. Subnetting is a process to divide a huge network into smaller networks. For example, subnetting provide security. Security in which sense? When we subnet the network, then by default, member of one subnet will not communicate to the another subnet. Subnetting always implement on host part. Subnetting always done on network requirement. Network requirement means how many subnet you want to create. So let's take an example. If you have, let's say this is the case one. In this case, we have this network 192.168.1.0/24 class C address with the default subnet mask, right? Here, these are the PC. If I'm using, let's say, .1 here, .2, .3, .4, let's say .100, with the default subnet mask, will they communicate? Yes? Anyone? If I'm using, let's say, 192.168.1.1, 1.2, 1.3, 1.100, they will communicate or not?
Yes, they will.
They will communicate, right?
Yes.
Because they belongs to the same subnet. Now, let's say this PC belongs to HR, this PC belongs to sales, these PC belongs to IT, let's say account. Now they all are able to communicate. In case 2, your requirement is users from the different team should not communicate with each other. So what you can do, one option you have, in every different department, you change the subnet. If you change the subnet, they will not communicate, correct?
So then you would use for each department, you would use a different third octet, right?
Right. So they will not communicate. But my requirement is I have to remain same into the same subnet, because if I use for every department with a different subnet, in that case, I'm consuming more IP subnet. Right? Maybe in my department, let's say HR department, I have only 2 users. For only 2 users, I'm using a separate subnet, which is not good. It's not a good IP address scheme. So what you can do, you can implement subnetting here. So you can here implement subnetting. So what subnetting will do, subnetting will that will be your major subnet, and it will logically break according to your requirement. So you can assign, this is my HR, this is my IT, sales, finance, like this way. Okay, and they will not communicate with each other. And your subnet is not changing. Your first 3 octet will be remain same. This is the subnetting basically.
So I have a question about adminning that. So, so you've subnetted it that way. Now you obviously HR, sales, accounting, finance, they can't speak to each other. But from an admin,
See, in the default condition, they cannot communicate. In default condition. But if you want,
go ahead.
If you want, in that case, you have to do routing. Clear now? Now ask your question.
Now, just from an admin standpoint, if I physically as the admin connect to the HR sales, accounting, then aren't I reconnecting those departments again by connecting to those?
Yeah, we need at least one router, and we have to implement routing in that case.
Okay, understood. So a router gives you the access, but doesn't give them access to each other.
Right. Okay. Just give me 2 minutes. Okay. So subnetting is the process to divide a huge subnet into the smaller subnets, and it will provide the security. How? So let's assume we have a network 192.168.1.0/24. How many IP addresses will be there in this IP subnet? Valid IP address. This is the network ID, correct? This is the IP or network ID?
That's the IP.
It's a IP. Yes,
Yep.
correct.
254 options. 4 options.
This is the network ID. Network ID is not assigned to any PC or any device. 192.168.1.1, that will be the first valid IP address.
So you have 255 addresses you can use.
254.
Right.
This is the valid IP. 1.255 is the broadcast address. Network ID and broadcast address not assigned to any PC or any device. These two addresses are self understood by every device. So on the client machine, we have to just use 1.1 to 1.254, which is the valid IP addresses, correct? And /24 means 255.255.255.0. So in this, these all IP address belongs to this IP subnet. That's why they are able to communicate. And what is the use of this broadcast address? If I send any data to this address 1.255, that will forward that traffic to that data to in this entire network, means to all the user. Clear this part?
Okay, so if you send something to that last IP, it sends it to everything in the subnet?
Exactly.
Okay.
Now, so this is the basic thing. Now our task is, let's say we are going to do some task. Task 1. In the task 1, I'm taking 192.168.1.0/24. This is the only one single IP subnet, right? In this, I want to make 6 subnets, 6 logical subnets. So you can understand like this way. Previously, this is the single IP subnet. Now what do you want in this? You want 6 IP subnet. So 1, 2, 3, 4, 5, 6. And every subnet will behave as a separate IP subnet. Clear this part till now? Okay.
Yeah, I understand the drawing. I'm not sure how you're going to get it to 6 different subnets.
Now, there is a point, subnetting always implement on host part. So, network, 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 and host. So this last octet is host. How many bits are there in the last octet?
254?
No. How many bits are there in the last octet?
Oh, 8 bits.
8 bits. So I'm just
Sorry,
writing
I thought
those.
you said ticks, not bits.
Okay. 1, 2, 3, 4, 5, 6, 7, 8. So these are the 8 bits in the last octet. Whenever you count the network, you have to count from this side, network. And when you count host, you have to count from this way. On every bit, there is a default subnet mask on every bit. So 1, 2, 4, 8, 16, 32, 64, 128. How it came? 2 raised to power 02, 2 raised to power 7. So 2 raised to power 0, 1, 2 raised to power 1, 2, 2 raised to power 2, 4, 2 raised to power 3, 8, like this way. Clear this thing? Any confusion? Okay. So how to do the subnetting? So there are 4 simple steps. First step, find out number of host bit for required subnet. My required subnet is 6, right? This is my requirement. So the formula is 2 raised to power n greater than equal to your requirement. So 2 raised to power n greater than equal to 6. So what will be the value of n here? Any idea?
3.
Yeah,
Exactly. So 2 raised to power 3, we are getting 8. If I take 2 raised to power 2, in that case, I'm getting 4. Means my requirement is not fulfilled. So what you can do, either it can be equal to or slightly greater than. First step is clear or not?
Well, so it would be a 3 then, right?
Right. So
Okay.
that means that 3 means first 3 bits are used to create the network. From those 8 bits, first 3 bits are used to create the network. First step is clear. Any question in this? Step number 2. So according to this calculation, we need 6, but according to the calculation, it comes 8. So 2 will be for the future use right now. Now, so networks are created. Now we have to identify how many users are there in this block. How many IP addresses can be there in this block? So per subnet. So the formula is 2 raised to power n node minus 2. N node minus 2, n node is the remaining bits minus 2. So how many bits are remaining right now? 5. 30. You can see 1, 2, 3, 4, 5, right? So 5 bits are remaining. If I'm putting into the formula 2 raised to power 5 minus 2, we are getting 30. So that means in every subnet, you are getting 30 users, valid users. And why we are doing minus 2? Because in every subnet, there is one network ID and one broadcast address. So those two are excluded because we can't assign those two IP addresses to the user. Third, as I told you, subnet mask always comes from the network bits. So right now, these 3 bits are the network bits. So your subnet mask change. So new calculated subnet mask. So new calculated subnet mask, whatever default subnet mask on that particular bit, you have to just add. So 128 plus 64 plus 32. 128 plus 64 plus 32. So you will get 224. And that 224 comes from the last octet, right? 1, 2, 3. The first 3 octet are on /24. So 255, 255, 255. This is fixed. And on the last octet, you are getting this will be your new subnet mask. Either you can write like this way or you can write like 27. Why 27? 8, 8, 8, and 3. We use 3 bits, right?
I'm still having trouble understanding where you got the 30, number two part.
Number 2. See, we had total 8 bits in the last octet, right? From those 8 bits, 3 bits are used to create the network. First 3 bit. How many bits are remaining now?
I got you. Go from the left. I was going from the right. That's where I was confused.
Clear this thing now?
Yes.
Third step is clear?
Yes.
Fourth one. Block size. Block size means after how many IP address your subnet will change. So the full is 256. Why 256? Because it starts from 0 to 255. So 0 to 255, 256. You can subtract your calculated subnet mask. So whatever value you will get, that will be your block size. Means (192.168.1.0/27). This will be your first octet. Then 192.168.1.32/27. The second one, 192.168.1.64/27. 192.168.1.96/27. So IP address change every subnet will change after 32 block size. So these are the network IDs. In this 192.168.1.1, it will go till 1.30, and 1.31 will be the broadcast address. And 32 is the new network ID. So you can see the valid users are how many? 30. And according to our calculation, 30. So that is correct.
So when you subnet it, the broadcast address becomes the second to, would be the last. Yeah.
Right. Broadcast IP will be the last IP in that subnet. Same way, 1.33 will be the valid IP in this subnet. It will go till 62, and .63 will be the broadcast address. Now,
And just to clarify, so all of these IP addresses will have the same subnet mask, correct?
right, and the subnet mask is /27.
And because that's what's telling it that each subnet is divided into 32.
Exactly.
Okay.
So all these users will able to communicate. They are able to communicate internally, but there will be no communication between them. If you want communication in that case, what you have to do, you have to connect with the router and you have to implement the routing part. Clear this thing?
Or just take out the subnet.
This is the subnet broadcast address. Subnet broadcast address, subnet, and in every block you will get a broadcast address. Clear this thing?
Can you scroll back up just a little bit?
Sure.
Okay, back down where you had the 256 minus 224.
Yes. Why 256?
256
Because subnet mask start from 0 to 255, right? In that last octet in the subnet mask, either it can be 0, it can be 128, it can be 192, it can be 224, it can be 240, it can be 248, 252, 254, or 255. Or other way, you can understand like in this way. In the last octet, there are total 8 bits, right? 2 raised to power 8, how many?
Gotcha. Okay.
Clear this thing?
Yes, clear.
Okay. Now you have to do one calculation. Here I calculate for 6 subnets, right? You have to calculate for 30 subnets. Try to solve that thing and let me know what will be the block size.
Well, I thought we had to calculate for 8 subnets with 30 IPs, not 30 subnets.
You have to calculate 30 subnets. Right now we are just doing subnetting.
Okay, I guess I'm confused here. I thought based on the required subnets, we did the 2 to the nth power was greater than or equal to the requirement, right?
No. Firstly, you have to calculate the number of bits used for creating the subnet. Let's say if I'm giving you the question with 30 subnets, right? So your first task is to find out the number of bits for that 30 subnets.
Oh, I'm sorry. So we're no longer doing the 6 subnets. You want us to figure out what you would need for 30 subnets?
Right.
Okay, sorry.
I have 32.
Okay, good. Next, step number 2.
Yeah, I think this one's stumping me.
Sorry, so what did you say the first number was, the first calculation?
I got 32. Is that correct?
That is correct. So 32 will be the subnets. So now you have to find out how many users valid IP will be there in those 32 subnets.
Yeah, in your number 2, I'm missing where the 2 to the 5th minus 2 is coming from.
in my first question, there are 3 bits used to create the network, right? So 3 bits are used to create the network, and node is the remaining bits. In your case, that will be C. How the 32 will come? 2 raised to power 5, right? There are total 8 bits. From those 8 bits, 5 bits are used to create the network. Now, how many bits are remaining? Only 3. So 2 raised to power 3 minus 2. So you will get 6. Clear now?
No, sorry, you went over it a little quick. Do it one more time. I'm sorry.
Okay, let's start from the beginning. I gave you the question, you had to calculate for 30 subnets, right?
Correct. Got that.
Your first step is you have to find out the number of bits, how many number of bits required for 32 subnets. So we have total 8 bits. From those 8 bits, we have to calculate network as well as host. So through the first step, step number 1, how many number of bits required to calculate the subnet? So 2 raised to power n minus 2 raised to power n. Sorry.
Go back up.
So 2 raised to power n means 2 raised to power 5. Clear this thing first step. Okay, hold on. Let me explain on the board. Okay. Step 1. Same 1, 2, 3, 4, 5, 6, 7, 8. Clear? You have to count network from this way, host from this way. So I'm not writing the complete step, I'm just directly writing here. So firstly, network required. So the formula is 2 raised to power n, and greater than equal to your requirement is 30, right? So here you calculate 2 raised to power 5, 32. This step is clear, right?
Yes, because you're going from the left, fifth octet, which gets you to 32.
How many bits are remaining now? 3. Total 8 bits, 3 bits are remaining because 5 bits we are using here for the network, right? So second part is valid host. So valid host is 2 raised to power n node minus 2, 2 raised to power 3 minus 2, 6. Total we have 8 bits. On those 8 bits, we used 5 bits to create the network. So remaining bits, how many? 3.
Yes.
Getting now?
Yeah, it's starting to click.
Yes. Calculate the next 2 steps.
Can you scroll back up to the next 2 steps?
Okay. So you need this thing. And these are the default values. You can note down these things.
Now I'm having trouble remembering the steps that we need to do to complete the task.
You can do one thing. You firstly note down this complete question, task 1, in a notebook, and then try to do the next question. Okay. So first note down the complete steps.
Okay, I think what's confusing me in your number 1 question there, found out number of host bits. It's not host bits, right? It's not coming from the right, it's coming from the left.
But the all bits are host bit now, because last octet is host. Okay. Now okay.
Yes. Okay, if you don't mind scrolling down the 3 and 4.
Can you scroll down just a little bit?
Yeah, I think I have everything minus the purge users. Somewhere I've messed that up. I've got 1, 3, and 4, I think.
And 30? 1, 3, and 4 where?
Just based on what Daniel said, so the step 2 is going to be 2 to the, and that's the remaining number of blocks, right? After you get step 1.
Yes.
So if you use like the first 3 blocks for step 1, you have the 5 remaining.
Yes. So
In that case, we have 3. In our case, we have 3 remaining, right?
Right.
So our final number is going to be 8 then?
Yeah, that's what I got.
Right. Block size will be 8.
You're broken up. I can't hear you. I'm sorry.
Yes, block size will be 8. So your first subnet will be 192.168.1.0. The next subnet will be 192.168.1.8. The next one will be 192.168.1.16. So that will be an increment of 8.
Which means we have 6 IPs per subnet.
Exactly.
And the subnet mask is .248.
Exactly. So subnetting is clear. You need practice.
Yes, that's exactly what.
Yeah, I understand it. It's just going to take some time for it to permanently mount in my brain.
See, if you are doing 5 to 6 questions, the steps will be in your mind. So rest of the calculation task. And in your exam, there will be 2 to 3 questions from the subnetting, superrating, and VLSM. So we cannot leave this topic like lightly.
Can you do step 2 again real quick and write it out for me? Because the 2 to the 5th.
See, total we have 8 bits. Right. From those 8 bits, according my task is this time 30 subnets. We had total 8 bits. On 8 bits, first task is how many bits are required to complete this requirement. So 2 raised to power n greater than equal to 30. So we are identifying, okay, 5 bits are required. So these 5 bits are used to complete my requirement. This is for the requirement. Now requirement is complete. The next thing is how many users will be there into the octet. So the remaining bits are 3. So 2 raised to power 3. Third step is calculated subnet mask. Calculated subnet mask on every bit. This is the default subnet mask. So first,
you're going to add up the total of the first 5 bits of the network.
Exactly.
Which gives
So
you the
will get
248.
Yeah, step 3 and 4 are clear as day. It's step 2 that keeps getting me. It's remembering that there are a number of bits.
Right.
So the dumb question that I have then is for the subnet mask, how do we, I forget how we get that slash number.
Slash number. By default number is /24, right? The default one. Because it is a C class address, 192.168.1.0. That is the C class address, right?
Yes.
Now, /24 plus 5, how many?
29.
Clear now?
Okay, so you take the original slash, then add the number of bits that you had to use to meet the requirement.
Exactly.
That's why when we did the first one, it was 3 bits, it gave us 27. That makes sense. Okay, thank you.
Yes. Any other question?
No, I think I've got it. Yeah.
So this is the C class subnetting. Same process you can do with the class B and class A. Class A is not required because the calculation will increase. Steps will remain same. The calculation will increase. Let's say if I'm telling you, okay, what will be the value of 2 raised to power 22? Okay. Again, it take approximate 10 to 15 minutes to complete that calculation task. And calculator is not allowed into the exam. Okay. So class A subnetting is not required. I'm going to explain class B subnetting. Clear?
Question real quick on something. Go ahead and save. So on the second step that you have right here, the valid host, 2 to the third minus 2.
2 to raise power 3 minus 2, because 3 bits are remaining now. 1, 2, 3.
Yeah, exactly. So it's always going to be the next one up minus 2.
Minus 2 in every subnet, there will be a network ID and the broadcast address, which is not assigned to anyone.
Understood. But what I'm saying is there's a pattern here. So your valid host, number 2 right here that's listed in orange, is physically 8 minus 2 equals 6.
Right.
It would be, if it was a next octave over, it would be 16 minus 2 would be 14.
Right.
Okay. All right. I mean, the math can be done simply.
Right. Okay. Now class B. So in class B, let's take an example 172.16.0.0/16. This is the default, right? 2 network and 2 host. Clear this thing? In class B, we have network, host, and host. Now, in class C, there is a problem. If you need more than 64 subnet, you cannot create into the class C. Why? Let's say you have 100 subnet in class C. If you need 100 subnet, in that case, what you have to do? You require at least 7 bits. In that 7 bits, network will complete. Okay, 128 network will be there. But when you calculate the host, 2 raised to power 1 minus 2, 0. So in that case, you will only getting network ID and broadcast address. You are not getting any valid IP address. So that type of network is not useful. So if you need more than 64 subnet, in that case, you have to move to the class B. So let's say in class B, I need 100 subnets this time. Okay. So this is my requirement. Now, this time, how many bits are there? How many host bits are there in class B? How many total host bits are there? 16, right? 8 from this subnet, this octet, 8 from this octet. So I can write like this way: 1, 2, 3, 4, 5, 6, 7, 8.
So just to be clear, the one that we did a minute ago was all class C subnet, correct?
Right. So this time we have total 16 number of bits. But one more thing, these 16 bits are from different octet. 8 from different octet, 8 from different octet. Now, same process. Network you will count from this side, host you count from this side. So, step 1. Find out number of bit for required subnets. So 2 raised to power n greater than equal to your requirement. 2 raised to power n greater than equal to 100. What will be the value of n here this time? If I use 2 raised to power 6, In that case, 64. So
8
6 is,
give you the 128.
yes. So 2 raised to power 7, 128. So that means 1, 2, 3, 4, 5, 6, 7. These bits will use. How many bits are remaining now?
There's 1.
No,
Should
Oh,
be
I'm
nine.
sorry, there's 9.
9. Number of valid host. 2 raised to power n node minus 2.
So that's
2
gonna
raised
give
to
you
power 9
7.
minus 2. First 2 steps are clear or not?
Yes, once we get the numbers memorized up top, it'll be a lot easier.
Okay. So subnet mask will be 1, 2, 4, 8, 16, 32. This is the next octet. So this way. Third step. Calculated subnet mask. So 128 plus 64, 32, 16, 8, 4 plus 2. You will get 254. So new subnet mask will be 255.255, and this 254 coming from the third octet, right? Fourth octet is not used. So in that case, 254 and the last octet is not used. So as it is 0. This is your new subnet mask, or you can say slash 23. Default 16 plus 7, 23. Yes. Any confusion here?
Where'd you get 510?
Okay, great. Then fourth one is block size. Same thing. Subtract from 256, 2. And the last octet is not used. So as it is 0. So this time your network will be like this way. 172.16.0.0 slash 23. The next will be 172.16.2.0 slash 23. 172.16.4.0 slash 23. This is the network ID. 0.1, it will start from 0.1. It will go till 0.255, then 1.0, 1.1, 1.254, and 1.255 will be the broadcast address. This time, this 1.0 is the valid IP, 0.255 is the valid IP address. Why? Because in the subnet, the last IP will be the broadcast address. If this will be my next IP address, so last IP will be what? This one, right? So the last IP will be the broadcast IP address, and the in between all IP addresses are valid IP addresses.
So on the second one, that would be 172.16.3.255
Exactly.
as your broadcast.
Right. Because only in that case we are getting this 510 users, no? From here to here, 510. 510 users, valid users. Step number 2. Clear this thing?
Out of curiosity, which is more common, the class C subnetting or class B subnetting?
See, it depends on what IP addressing you are using in your network.
Like what the requirements are?
No, requirement means if you have smaller network, then you can go with the class C. If you have big network, let's say in your organization there are thousands of users, then obviously you have to move to the class B.
So it's just, yeah, it's based on the size of the subnets then, or
Right.
the number of subnets that you need.
Right.
Okay.
Yes. Any other question?
Stupid question. 2 to the 7th is 128 because you're doubling it 7 times.
Right.
Okay, I'm good. I'm good.
Okay. Last example in this. In this, you need, let's say, 1,000 subnets. Okay. So in 1,000 subnets, same way, network, network, host, and host. So now, step number 1, network. So network 2 raised to power n greater than equal to the requirement. So here you will get 2 raised to power n greater than equal to 1,000. So if you calculate this thing, you will get 2 raised to power 10 and you will get 1024. Okay. So 10 means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Clear this thing? Step number 2, valid host 2 raised to power n node minus 2. So 10 bits are used to create the network. So remaining bits are 6. 2 raised to power 6 minus 2, you will get 62. Third one is calculated subnet mask. If you see, this first octet is full. First octet full means dot 128 plus 64. So if you calculate all these, you will get 255.192. So your new subnet mask will be 255.255. This is the fix. Then this you will get from the calculation. This is clear or not? Step number 3. Because the first octet is full, and when you add the all values on the default bits, then you will get 255. So that's why if all bits are network bits, then you are getting the 255. Clear now? Yes, Daniel, Craig, any question here?
No, that makes sense. And then, so it's going to be a /26.
Exactly. Fourth one is the block size.
Yeah, sorry, I'm keeping up with you. I'm just trying to take.
So here is a point into the block size. Once your block is full, means all bits are used, then you have to put 0 on that block. The third block will be 0. Then the last octet 256 minus 192. So that will be 0.64. So let me write here. If any block full used in block size, put 0. So now the block size is this. So how the network will go? 172.16.0.0/26. So next will be 172.16.0.64. Next will be 172.16.0.128. Like this way it will go. 172.16.0.1, it will go till 0.62, and 0.63 will be the broadcast address. So this is the complete subnetting. Class A subnetting is not required, and no one will ask class A subnetting because the calculation task is there. Steps will be same.
So I'm confused as to why on the last example, it went the 172.16.0.1 and then .1.1, but on this one, it only goes up to 63 and then goes to the next.
Your block size is 0.64, na? That's why on every 64 IP addresses, your subnet will change.
Oh, I'm sorry, because it was completely full on the third octet, so it's always
Right.
going to be a 0.
This one, this 0. I write one point here. If any block full used, then put 0 on that block. See, this block is fully used.
Right, so because that block is fully used, the third octet's always going to be 0.
Right.
Gotcha. Okay.
So this is the end of the subnetting. Let's take a break now. Is it fine?
Yeah, that's fine. How long are we taking for lunch?
45 minutes.
Okay. Are you staying logged in?
Sorry?
Are we staying logged in, keeping everything up?
Not an issue. Okay. Is there any issue in the subnetting? Means, can we implement directly subnetting into the production environment?
Yeah, I think we can.
Okay. Is there any issue? Any problem we'll face?
As far as implementing subnetting,
Yes.
well, you have to make sure that the network addresses aren't already being used.
Okay, that's correct. If you see the calculation task, in every block, there are equal number of users, correct? The number of valid hosts is same in every subnet, correct? For example, in the last example, we calculate for 1000 subnets, right? In every block, we are getting 62 IP addresses, correct?
Yes.
But
Equal across the board, right?
so subnetting is known as FLSM, fixed length subnet masking. Subnetting is also known as FLSM. FLSM. Fixed length subnet masking. No. Here we are getting an issue in every block. Equal number of valid IPs. But in production environment, in every department, there are different user requirement. For example, like in HR department, how many HR we have? 5, 6 maximum. Then IT team, let's say 10. Sales team, let's say 60. So when the requirement, when in the departments, we have different user requirement, in that case, subnetting fail. Because subnetting will provide you the equal number of user. So maybe that block will be suitable in one subnet, but in some department, there are, let's say, 100 users requirement. In that case, subnetting fail because your block size is allowing you only 60 users or 64 users. So if in the department you have unequal user requirements, in that case, you cannot do subnetting. So in that type of scenario, you have to do VLSM. Unequal user requirement. Then subnetting fail. And solution is VLSM. VLSM is variable length subnet mask. Variable length subnet masking. No. VLSM. VLSM is used to reduce wastage of IP addresses. So here we calculate the block size according to the user requirement. How many users we require, how many IP addresses we require in that particular block. So based on that, we will do the calculation task. Again, VLSM is done according to cost requirement. VLSM is implement on host part. VLSM provide scalability and flexibility to network. VLSM provides security. Okay. So now see this example carefully. This type of example will be in your exam. Okay. So here the 60 user means there is a switch connected. In that switch, there are 60 users. Or you can assume these are the LAN. And 2 IP address we require between the routers. Okay. Router to connect router to router, at least 1 IP address we required. Okay. So in that particular link, we need 2 IP addresses. And on every router, these are the requirements. My major subnet is 192.168.1.0/24. This is my major subnet. I had to implement, or I have to complete this requirement based on that IP subnet. So if I'm doing subnetting in that case, first thing, let's take an example of subnetting. If I'm doing subnetting, what will happen? How many networks are there? 1, 2, 3, 4, 5, 6, 7. So there are total 7 subnets. Okay. If you calculate for 7 subnet in that, it will become the first question in the subnetting. And every block you will get 32 IP addresses. So 32 IP addresses suitable here. 30 user will be suitable here, but it is not suitable here because you need 60. If you put 30 block size here, then 28 IP address will be waste. 28 IP address will be waste. 20 IP address will waste. On 50 user requirement, it's not scalable. 6, again, you have wastage of IP addresses. So the network where you have different user requirement in every block, in that case, you cannot use subnetting. So there is the solution of VLSM. So means on that particular subnet, you have to implement VLSM. How? This topology is clear? Any question in this? In topology?
So sorry, what are the number 2 on each of those connections? Does that mean there's 2 IP addresses?
Right. So at least if you want to connect R1 and an R2, so at least one IP address you require here, one IP address you require here, correct?
Oh, for each of the routers.
Right.
Gotcha. Okay.
And you said,
But then wouldn't there be, I'm sorry, just to clarify then, if you've got 2 IP addresses between router 1 and router 2,
right,
then why do you have 2 IP addresses between 2 and 3? Because router 2 already has an IP address.
see, the link is between R1 to R2. If you are connecting R2 to R3, then this is the different link, the link between R1 to R2. If you want to connect R2 to R3 in that case,
you have to do it with a separate IP address?
exactly.
So it can't use the IP address that it's using to connect to R1. It has to use a separate one.
Right. And the subnet must be different between the link. Let me give you an example. Let's say here you use 12 network IP address. Let's say 12.0.0.0 network. So you can use 12.1 here, 12.2 here. So 12.3 and 12.4 you cannot use here. So either you can use here 13. So 13.1 is here, 13.2 is there. Like this you can use. Between the link, subnet must be changed. Clear? Any question in this?
I understand you're telling us that it's clear, but I don't understand why.
You don't understand? Why?
Yeah, do you get conflict? I mean, why can't you use the IP address that it was already assigned to make the connection between R1 and R2? Why does it have a separate IP address?
I'm going to guess it's because they're different subnets and you don't want to use, or you're not allowed to use the 4th octet on 2 different subnets, right?
Right.
Yeah, but you're only changing 12 and the 13, not the 4th octave. So the 4th octave is the far left.
See, there is a simple concept.
Well, but remember, it's a class C subnet, so you're only doing the 4th octet. So you're not going to be able to space that out subnet wise, you have to do an entirely different first octet for the subnet. Am I correct? Am I understanding that correctly?
Right. I will show you this thing, like why we are using the different IP subnet. After this topic, we had to start labs. Then I will show you like why IP address required different IP address. Okay. Now, how to calculate this thing and how to solve this thing? So first thing, you have this IP subnet. Right? In this host requirement, when you are doing subnetting, your first target is you are calculating firstly network, right? Your first step is find out the number of bit for the required subnet, right? On that time, I'm giving you how many subnet you require. But this time I'm giving you how many hosts required in that particular subnet. So the calculation is reverse this time. Okay. So host requirement block size, and whatever we are writing this na /24/26, that is known as CIDR notation. CIDR or CIDR value. CIDR is classless inter-domain routing. I will come to that point. So if you see the network, so one requirement is 60, 50, and 30, 10, 30, 10, 6, and 2. These are my requirements. Any question till now?
Yeah, actually, you have switches there. Do those have to have separate IPs as well?
It depends which switch you are using. If you are using layer 3 switch, then in that case that require a IP address. If you are using the layer 2 switch, that doesn't require any IP address. Because layer 3 switch require a IP address. Layer 3 will not understand, layer 2 will not understand the IP. Okay. So see this calculation carefully first. So I'm doing for this 60 host. So for 60 host. So this time I'm giving you host information. So if you have host information, then how you will calculate? Now, number of valid host. So what is the formula at that time when we are calculating the host? Have you remember?
2 to the n minus 2.
Exactly. 2 to raise power n node minus 2. So this is the class C, right? So same way in class C, how many bits are there? 1, 2, 3, 4, 5, 6, 7, 8. Network from this side, host from this side. So if you calculate this thing, what will be the value of n node here?
Be 7.
Sorry? 7.
7.
No, if you take 7, in that case, 128. It's large.
It's
2
6.
raised to power 6.
6, I'm sorry. 6. It's the one underneath it. I'm sorry.
So 2 raised to power 6 minus 2. So you will get 64. That is nearly equal to. Okay. So from this calculation, I find out 6 bit are host bit. That means these 6 bits are host bit. How many bits are remaining for the network?
2.
2. So whatever steps are there into subnetting 1 and 2, in VLSM, step number 2 will become first and step number first will become second. Rest of the things are same. Third, calculated subnet mask. What will be the subnet mask? Tell me.
It would be 1 plus 2.
No. Remember one thing, subnet mask always comes from network
It's going to be
bits.
192.
Exactly.
Oh, I see. The other way around. Sorry, I did it.
So 128 plus 64, 192. Then fourth step is block size. Then
64.
right. So this calculation is clear, right? So now through this calculation we find out if we have 60 hosts, then the block size will be 64 and the CIDR will be /26. Why 26? By default 24 plus 2, right? Any confusion in this?
No, that makes sense.
Okay. So tell me what will be the value for 50 users? Calculate and let me know. What will be the value? What will be the block size and CIDR value for 50 users?
Wouldn't it be the same exact thing?
Right. That will be 64 and what will be the value for 30?
32 blocks.
30 users this time. 30 users.
Right, it'd be 32 blocks.
32 block. Okay. Slash.
I didn't make a note of how to do the math.
27. If you go with 10 user, then
The block size is 16.
block size will be
16.
right 16.
And then it would be 28.
And when you go with the 6,
It would be a block size of 8.
8.
And then it would be 29.
Any issue in this table?
So in short, you're just reversing step 1 and step 2 for VLSM.
Exactly.
For Class C. Is it any different for Class B?
No, steps will be same. You have to just understand the method. And you have to take care about the calculation task. The process will be same. Okay. So firstly, in the VLSM case, yeah.
I'm sorry, before you move on, I did not take note of the math, the +2. Is it always +2 on the, sorry, if you scroll up a little bit, the CIDR?
Mm-hmm. CIDR on plus?
No, remember, Daniel, it's always going to be the /24 for this one anyway. It's the /24, but then you're going to add the number of bits counting from the network side that are used that you add up to get the subnet mask.
Basically what's left over, right?
So if you add 3 of them, you're adding +3 to 24. If you add 4 of them, you're adding 4 to 24. And that's how you get that number.
Default value plus network bits. So default value is 24. And let's say for the 60, you are using 2 network bits. So that's why it came 26.
Understood. Okay. That's what I did not. Let me take note of that.
It's done?
Yeah, I'm good.
Okay. So in VLSM case, you have to find out this table firstly. So once this table is done, then what you have to do, take a scale, your IP address will be from 0 to 255, right? So firstly take the highest requirement. Your highest requirement is 60. So for the 60, the block size is 64. So that means 0 to 64. You can assign here.
Can you take your screen down to like 90%?
This one?
No, the zoom. Take it from 100 to 90%, bottom right. Shrink your entire screen size to 90%.
Okay. We cannot custom the size because either it is 50 or 100.
Oh, okay, never mind. You can go back to 100. That's easier for you.
Okay. So now take the highest requirement first. So here we need 60 users. So for the 60 user, you can take this block size 192.168.1.0 till 63/26. Clear? Then again, here we need 64 block size. So from here, you can take 192.168.1.64 to 127/2. So let's say this is A, B. Then the highest requirement is 30. So for 30, you can take 32 block size. So if you take 32 block size, so it will be till 160. So here you can assign 192.168.1.128 till 159/27. Then the next biggest requirement is 10. So for the 10 user, there is a block size 16. So 176. So here you can assign 192.168.1.160 and it will go till 175. Then you require 6 user. For the 6 user, there is a block size 8 block size. So 8. So here you can assign 192.168.1.176 till 183/29. Then so now here you can assign 192.168.1.84. It will go till 1.87/30, and here you can assign 192.168.1.191/30. This is your VLSM. And if you see,
I'm confused by something. I thought you said that when we were doing this, you couldn't have the two IP addresses between routers have the
right,
same subnet number.
right? But if you see, this is the different. This subnet is different. It belongs to this network ID, and this belongs to this network ID. Subnetting is there.
Oh, okay, I gotcha. Because the subnet is the host, not the network.
Exactly.
Right.
Okay. So this is the VLSM, and if you see, after 192 till 255, these IP addresses are free. So in the future, let's say you need 64 block size, you can take 64 block size. If you need 32 block size, you can take 32 block size. If you need 4 block size, you can take 4 block size. Like subnetting, the block size is not fixed here. So this is the VLSM, variable length subnet mask. In every block, there is separate user requirement. Understand this question carefully, because there will be a question in your exam. They will draw a picture like that, and they will give you the user requirement like this, 50 user, 6 user, like this way. And they will ask what will be the suitable network here. So there will be some options. You have to select the best option.
So maybe I missed something, but what is it then that's isolating each subnet from the others if you're using just sequential network IDs?
See,
is it the subnet mask number that changes to make them separate subnets, or what are you doing?
Yeah, they will change this value, /CIDR value. So /CIDR means they are changing the subnet mask, because that slash value represent how many network bits are there, and your subnet mask depend on the network bits.
Okay, so that slash value then is denoting that there's only that many IP addresses on that subnet.
No. That slash value represent what will be the subnet mask. For example, if I'm writing here this /26, so in the /26 means this /26 means 255.255.255.192. Clear now? The slash value represent the subnet mask.
Okay, so on the far right, where there's still a 26, they're still on the same subnet mask, right?
Right. So this /26, this /26, they are sequential if you see, but they will not communicate, because these 1.1 to 62, those IP address belongs to this subnet, and 65 to 126, they belongs to this IP subnet. If you want to communicate, then you have to do routing on R1, R2, R3.
And is it because they're on different routers that makes them isolated from each other?
Right, you can say that.
Okay.
Because router divide the broadcast domain.
Okay, so I got you. So the router is acting as a differentiator between the two subnets, even though the numbers are sequential.
Right.
Okay, that makes sense. Thank you.
So this VLSM is clear or not?
Yeah, and do you have to take in consider the broadcast address?
So broadcast address will be not considered. Reason, whenever you assign the IP address and subnet mask to any device, any PC, that device will automatically calculate what will be the network ID and what will be the broadcast address.
Understood. So for the two in the center, for our two IP addresses between routers, it identifies them there.
See,
You had to use 4 numbers because your block size was 4. So even though you're not using all 4 numbers, you still had to assign 4 numbers to that subnet.
hold on.
Is why it went from, it's why it went from 184 to 187, is because you have to assign 4 numbers to that.
See, this 184 is the network ID, right?
Oh, I see. It's an 84. I'm sorry. I was reading it as 186. That's what was getting me.
This is, so here you can assign 185. Here you can assign 186. 187 will be the broadcast address.
Yeah, that makes
sense.
Now? Yes. I was reading as 186. I apologize, guys.
Not issue. So this VLSM is done. Any issue in this?
No, and just, I mean, it cuts down your wasting of IP addresses, but you're still going to end up wasting some.
Yeah, and the wastage is only network ID and the broadcast address, because that is mandate in every subnet. There will be one network ID and one broadcast address.
Yeah, but if you only, like in the case of the 60 users and the 50 users, you're officially wasting 10 users.
That, because we haven't control on that. That is coming automatically with the calculation.
Correct. Yeah, right. I understand. It cuts down on some of the wastes, not all.
Right. Okay. So on subnetting VLSM, there will be 2 or 3 questions. So what kind of question will be there, I will show you tomorrow. So today you have to practice this VLSM and
So I have a question.
subnetting. Yes.
Regarding that test. So I assume that since you're writing this stuff down, that we're going to get this to reference?
Which one?
All of these PNG files, because I have not been duplicating your notes.
This one, I will share all this stuff.
But can we reference them during the test?
For the test, I will show you some question. I will give you some questions, like real questions, real production questions, case studies.
No, I understand that. What I'm saying is I am not taking notes verbatim like you're writing them down, because you're writing them down and I thought we were getting them. What I'm asking is, can I reference the PNG files while I'm taking the test?
But these are not allowed in the exam center. How you will take in the exam center?
I don't know. I thought we would be taking it virtually like we're taking this training.
No. In the exam center, like you will be getting one PC. In that PC, you cannot take screenshot, you cannot take printout, nothing will be there. There will be one application. In that application, they will run the exam. Only that exam will work on that PC. Okay. But in the exam, calculator is allowed, and that calculator will be the virtual calculator, not physical one.
That's good to know. I wasn't aware that the test was not taken at the time of this training.
Okay. When you are planning for the exam, after this training or after some time?
Wasn't sure. I thought it came with this. So that's what you're telling us is news to us. Or at least
I will recommend you one thing. Firstly, 1 or 2 days, just go with the concepts, whatever topics we are discussing. Okay. And after that, I will give you some practice test. Go with that practice test. Okay. So if you are comfortable with the practice, whatever test I'm giving you, if you are comfortable with that, then you are ready for the exam.
Understood. Okay.
One more calculation task. The next one is VLSM is done. Then next one is supernetting, also known as CIDR. CIDR is classless interdomain routing, also known as root summarization. These are the three different names, but the process is same. Supernetting is a process to increase number of hosts within same class. Within same class. Okay. Let's say we have two companies, A and B. In this company, the network is 192.168.0.0/24 1.0/24. How many valid users will be there in this site? Yes, how many users will be there in this site? Any idea?
254.
Right. And here?
Same thing.
Same thing. Can these 254 user communicate with these 254 user in default condition?
No.
Not at
No.
the moment.
Why? Because they have the different network ID address. If you want to communicate in that case, you need a router and you have to do routing part. Clear till now? Now, let's take company A take over company B. Now, these two companies are a single company. Company A take over company B. Now they are a same company. Now, the task is we have to communicate all these 510 users. Let's say total users are 508. I want to communicate them, and management is not allowing me to purchase a router. So without router, we have to communicate all these. Now, there is a condition. Two user can communicate in default condition if they have same subnet ID. Clear? Any question? Two users can communicate in default condition if they have the same subnet ID. If they have different network ID, in that case, you have to do routing. So now, if you want to communicate, all these 508 users, what they require? Same subnet ID. If all these users have same subnet ID, they can communicate. Clear this point?
Yes, that makes sense.
Now, so supernetting, CIDR or root summarization is, supernetting is a process to increase the number of hosts within the same class. Means the class will not change and the number of user will increase. How? To implement subnetting, we have two processes. One process I'm going to explain this time here, and second process I will explain with EIGRP protocol. Now, number of valid user. Formula is 2 raised to power n node minus 2 greater than equal to 508. What will be the value of n node here? 2 raised to power 9. You will get 510. If you take 8, then 256. So your requirement will not complete. This step is clear or not?
Say the last part again. If what?
This one. See, we have total number of user now 508. So I'm just calculating how many bits I required for 508 users. So right now I'm getting, I need 9 bits. It's a class C address. Class C address, right? It starts from 192. So class C address. So class C
is going to be 255.255.255.0.
Right. So I can write this way, 32 bits, I can write this way, 1, 2, 3, 4, 5, 6, 7, 8. So whatever is the network bits, I write with the 1, and the host bit I write with the 0. This part is clear or not? IP address, IP version 4 is 32 bit. Those 32 bit I write 1 as the network bit and 0 as the host bit, just for the representation. Now my requirement is 508. I just find out I need at least 9 bit to complete my requirement. Means if I want to make a common network ID, then at least 9 host bit I required. But if you see in this, how many bits I have? Only 8 bits. Clear? I need 1 more bit. So what I can do, I can borrow 1 bit from network. So previously subnet mask is this.
So you can change it to 254.1.
So now this will become 254. 0 will be 0.
So instead of adding a 1 like you would for the IP address, for the subnet, you subtract 1.
Right. Because of this requirement, we have to complete this requirement. So we find out we need 9 bits. We have 8 bits. So whatever is the extra bit we required, we can borrow from the network bit. So if the last bit is 0, means the host bit, then subnet mask will change accordingly. Then new subnet mask 255.254.0. The next step, block size 256 minus 254, you will get 2.0. So your block size is 2.0. So your network will be like this way: 192.168.0.0/23, 192.168.2.0/23. So if you see this subnet 192.168. Start from 0.1, it will go till 0.255. This octet is full. Then 1.0, 1.1, 1.254. These are 510 users. So if you want to communicate all these two users, the common subnet ID will be 192.168.1, sorry, 0.0/23. That will be the common network ID for all these users. So if you use this /23 subnet mask, they all can communicate with each other, because both these network ID coming under this IP subnet. If you go down into the calculation, you can see that thing. See, right? Yes, ask any question if you have. Sometime you will be confused in the exam. They will give you the question and you will confuse, like, okay, I have to do subnetting or I have to do supernetting. So remember one thing. Remember the default bits. For example, if they are giving this thing 192.168.1.0, let's say /22. So tell me, this IP address belongs to which class? Class C. And in class C, what are the default bits?
It's going to be
The default number of bits is 24, right?
Network host, so it's 24, right?
Right? So if in the question, let's say here, if in the question, if they are giving /22, means
that means that 2 bits from the third subnet number were used for host numbers.
let's say if the default bit decrease, for example, like in this question, so you have to implement.
So it would be.
You just said that's going to be 254.
No, it's 253.
That is 253. I'm just giving an example. Okay, let's take 253.
No, I see. I understand. Yeah, Kirk's right. I was just.
Okay, so if the default bits are decreased, then subnetting, and if default bit increase, then you have to implement subnetting or VLSM. Clear this thing. So if you remember, in subnetting and VLSM, my number of bit increase /26, /27, /29, /30, like that. Clear? And when we are doing subnetting, the number of bits are decreased.
You mean supernetting?
Super.
Right.
Subnetting, they go up. Supernetting, they go down.
Right. So on this point, we complete the basic part. Now we have to discuss about IOs. Yeah. IOs. Internetwork, operating system. So IOS is basically operating system on Cisco router and switches, which perform routing, switching, and security functionality. Router physical ports. So on the router, or you can say router front panel, on the router there are some ports which is present on the device. serial 1, serial 2. So these are serial ports. These are fast Ethernet port, console and auxiliary. This is power button and this is power supply. Whenever you purchase router, let's say any router, 2600 series, 2800 series, 2900 series, any router above 2600 series, by default, you will get only the fast Ethernet port, console port and auxiliary port. Serial ports you will not get. For the serial port, you have to purchase additional card and you have to plug into the router. So for example, let me show you. Like this way. Like this way, you will get fast Ethernet port, console port, auxiliary port, power button and power supply. This left side slot is free. So you have to unscrew that and you have to plug the card inside this. Like this way. This card. So this card you have to purchase additionally. So it depends like what kind of ports you required. If you need serial card, you can take serial card. If you want to increase the number of fast Ethernet, you can take that card. So you have to select the card and you have to plug in into the device. So serial ports used to connect router to router. Here serial DTE DCE cable used. Serial DTE DC cable is like this. like this. So this is the serial cable. Advance of this is smart serial cable. Only the size is reduced. The functionality wise, everything is same. Fast Ethernet port. Used to connect router to router, router to switch, router to PC. Okay, so we have two options. Either I can connect router to router with a serial cable, and I can connect with a fast Ethernet. So which one will be the benefit? Like, okay, on which connectivity will be good? So the point is, on serial link, serial ports, on serial link, bandwidth will be 1.544 Mbps. Whereas on fast Ethernet, the bandwidth will be 100 to 1000. Console cable. Console port used to access console of device. Console port used to access directly. Means we are connecting directly through the console port. Auxiliary port used to connect remotely via aux port. Here on the auxiliary port, firstly modem will connect. On modem, that modem will connect to the external world public network. We will assign a public IP to the modem, and through that modem we can directly access the device. So these are the ports on the routers. Any confusion in the ports? Any question you want to ask?
No, that's clear.
Okay. Next. Router component. So on the router, you will get ROM, RAM, NVRAM, and flash. So these are the component, or you can say these are the memory into the routers. So ROM is Read-only memory. It hold post and bootstrap program. Now post is power on self-test. Any idea about power on self-test? See, power on self-test is, let's say you are starting your laptop. So you are doing power on. So once you click on the power button, then the power supply will go to the BIOS first. That BIOS is having that information, how many ports are present on the device. So electricity will go to each and every port and reverse back with that information, all ports are working fine or not. So if some ports are missing or some ports are not working, at the booting time, it will give you that information. So for example, let's say on the desktop, we are not connecting any mouse. And if we start that device, that at the booting time, it will show you one thing, the pointing device is missing. So how you are getting that information? You are getting that information through the post process. Next one is bootstrap program. Let's say on your system, you have multiple operating system. So it will give you that information through which operating system you want to log in. Clear?
Yeah, that makes sense.
Next one is RAM, random access memory. Random access memory hold running configuration. NVRAM, non-volatile RAM, it hold a startup configuration. And last one, flash memory hold iOS image. Next. Router booting process. Router booting process. When power on the device, firstly, post will run. Post process will run. It will verify your all ports are working fine or not. Okay. Let's post process complete successfully. Then router look for IOS image, and the IOS image is on flash drive, sorry, flash memory. It load IOS image from flash. So once the flash is loaded, then a startup config. Then router look for the startup configuration. If startup config in NVRAM, then router boot with a startup config. Otherwise, it will give you default setting option. So it will give you the default setting option, means do you want to continue with the default configuration dialog? So
Sorry, what was NVRAM stand for again?
non-volatile RAM. Non-volatile RAM. Clear this thing now?
And I'm sorry, can you let me see step 2 again? Sorry, I was taking a note on it. I missed. And then scroll down where I can see the end of file. Okay.
It's done?
Yes, sir.
Okay. So now let's start with some practicals. Okay. Let's say this is my router. On that router, there is a console port. So sorry. if you want to access this router on that PC, that means you are accessing this IOS, because that IOS is the operating system and you are accessing through the console port. So if you want to access this IOS or this console on that PC, this PC requires some application, and that application can be PuTTY, Teraterm, and Hyperterminal. PuTTY and Teraterm, these are the third-party application. Hyperterminal is the Windows application. If you have Windows XP, that Hyperterminal will be by default installed. If you have Windows 7, Windows 8, Windows 10, in that case, you have to download this Hyperterminal utility from the Microsoft, and then you have to install into the PC. Clear this thing? No. Next thing is router modes. So once you access the device, once you access any router or any switch, so firstly you will be on this prompt here. This thing is known as enable mode. If few command will work here, if you want to move into the next mode, here you have to type enable and then enter. So once you enable and enter, the prompt will change, then you will be into the privilege mode. So once you are getting this hash symbol, privilege mode. So in the privilege mode, you will run all the show and verification command. So for example, show IP interface brief, show version, show flash, all those commands.
I'm sorry. You said when you first enter, you're in enabled mode, or you have to type in enabled, then hit enter to go to enabled mode?
No. This is the enable mode. If you are only this option like greater than sign, this mode is known as enable mode. To move enable to privilege, you have to type enable and then enter.
Understand.
Clear now?
Yeah.
Okay. So this privilege mode, in this privilege mode, you can run all the show and verification commands. Now, if you want to configure device specific, for example, you want to give a name to the device, then you have to enter into the global configuration mode. So here you have to type configure space terminal. In short, you can write config T. So once you type configure terminal, then your prompt will again change and you will be into the config. This mode is known as global configuration mode. Any confusion till now?
I have a question. Are these commands sequential? Like, do you have to enter privileged mode to be able to enter the configure command, or can you do it from the basic?
Yeah, these are the sequential.
Okay, so you have to enter privileged mode, then you can do the configure command?
Right.
Okay.
Okay. So do one thing. Try to log in with your lab, virtual labs. There will be discovery number 1. Open that discovery. So we'll do the lab side by side. So I will show you the command here and you can run the command there. Login with Cisco Learning Labs. Okay. I'm just coming in 1 minute. Let me take a glass of water.
Kirk, are you having trouble getting in?
Yes.
Yeah, mine is telling me login failure when I'm using the same information I used earlier.
Yeah, same here.
Yes. Have you logged in with Cisco Labs?
The labs actually are not letting us get in, both of us, with the same username and password we used earlier. I had it open, but it timed out and it's telling me a login failure now.
Yeah, you have to log in once again.
Oh, remember, Daniel, it's not your Cisco username and password. One that he gave us.
I can't understand you, Kurt. You broke up.
I said it's not your Cisco username and password. It's the one that he gave us earlier to enter in.
The username and password to access the lab, I shared you on the chat.
Oh, okay, yeah. The chat doesn't hold it that long. I can't see it in the chat any longer.
Hold on.
Mine was still there, Daniel.
Last one.
Virtual.
So once the putty will start, you will be on R1 and greater than sign, correct?
No, I just have a green cursor. It says R1, but it doesn't have the sign, but I'm assuming it's where it needs to be. However, it
Share
keeps.
your, okay, share your screen. Let me see.
Where do I share my screen at?
Yeah. Share your screen.
I know where.
There is an option.
I see.
Share screen.
So my putty window keeps closing. Is there a reason for that?
Yeah, mine as well.
Let me see. Click here. Enter.
And then here in a few seconds, it's going to close.
No, click on enter. Have you installed that software?
Say it just closed. What software?
Go back. We download one software. Remember Cisco terminal.
Yeah.
Have you installed that one? Yes, this one.
Yeah, I did this. I'll do it again. I'm going to try it again.
Once again.
This is virtual, right?
Right, it's virtual.
Okay.
Which window you have? Windows 10?
Uh-huh.
Maybe that
See, it
window.
just closed.
Yeah, maybe the window is giving some issue. Maybe it need a reboot.
I can reboot, but it's going to, Kirk's having the same issue.
Yeah, that's why I haven't installed that software here in this local system, because if I restart, that session will close. So
Right.
I cannot show it here. What will be the solution? Okay. So when you access the console, you will get this prompt. This mode is known as enable mode. How many commands will work here? You can simply type question mark here. So once you type question mark, all possible command on will be visible in front of you. So on this mode, you can run all these commands. Okay. So as I told you, if you want to enter into the next mode, you have to type enable and press enter. So your prompt will change. This mode is known as privilege mode. Now, how many commands you can run here? You can simply type question mark. Again, it will give you the complete list. Next, if you want to do some router specific configuration, so you have to enter into the configure mode. In short form, you can type config T. So you are into the configuration mode. Let's say if you want to change the name of the device. In that case, you can type host name and the name of the device. Let's say I want to give R1. You can see the name is changed. Clear this thing? Any issue till now? Yes, Daniel, Craig. Any issue?
No.
No, that makes sense.
Okay. So now, firstly, I'm going to discuss the privilege mode commands, all the privilege mode command, basic commands. Then we'll move to next mode. So let's say if you are into the configuration mode and if you want to go back into the previous mode, so simply type exit. So you will be into privilege mode. Again, if you want to exit through the privilege mode to the enable mode, simply type exit. Okay. As I told you, privilege mode is used for all the show and verification. So for example, first command is show version. If you want to check what is the iOS version on this router, so you can run show version, and here you will get the version is 15.2. And here it is showing there are 4 Ethernet interface, 4 serial interface, and 64 KB is the size of the NVRAM. So first command is show version. Next command is show flash. Okay. Show flash command is not there in this router because that router is a virtual router. Otherwise, if you run show flash command, it will give you what is the name of your iOS image. Next command is show IP interface brief. So in show IP interface brief, it will give you the information how many ports are there. The ports are enabled or not. Have you assigned IP address or not? So you can see Ethernet 0x0 is assigned with 10.10.1.1 and the interface is up. But these rest of the interfaces are down and these are showing administratively down. Means those ports are manually shut down. Next, show running configuration. Show running config, it will show you the running configuration of the device. If you run show startup configuration, in show startup, it will give you the startup configuration of the device. So when you run show run and show startup configuration, in both the cases, you will get the same kind of output because whatever is your startup configuration, when you start the device, that startup configuration will become the running configuration of the device.
Hey, if we're supposed to keep up with these, you're going to have to slow down a little bit if we're taking notes.
Sure. Basic commands. So first command we discuss about show version. This command will display the current iOS version. Show flash. This command will display the iOS. What is the name of the iOS? So when you run the show flash, you will get a file, for example, like C2600.122. Like this, and the extension will be .bin. So whatever file you are having with .bin extension, that is your iOS image file. Next is show running config. It will give you the running configuration of the device. Show startup config. It will give you the startup configuration of the device. Show IP interface brief. This command will give you the information about each interfaces briefly, like have you as an IP address or not, the interface is up or not. If you want a detailed information about any port, so you can run show interface and the name of interface, for example, like fast Ethernet 0x0. So it will give you the detailed information about physical interface fast Ethernet 0x0. Next is show history. In show history, it will give you the last 20 command history. And again, this command is IO specific. Maybe in some router, you will get only 10 commands. In the new iOS version, you are getting the 20 commands. Clear? Let's say show history. Okay, one more thing here, short command will work. So if I type sh means that is show. In show history, I run all these commands till now. If you run show IP interface brief, it will give you all the interface information. There is a interface serial 1/0. So show interface serial 1/0. So so if I run this thing, show interface serial. So now I'm getting the complete output of this particular port. So here you are getting the interface is administratively down, means the port is shut down right now. Line protocol is down. See the MTU. When I'm discussing the theory part, then I told you on every port, the size of MTU is 1500 bytes. On serial link, the bandwidth is 1.544 Mbps. Here they are showing into the kbps. And here you can see encapsulation is HDLC. So on the serial link, encapsulation can be HDLC, can be triple P. Clear this thing till now? Next, show clock. So this is the time. If you want to change the time, clock space set is the command. Then firstly hours, then minute, then second, then date, then month, then year. This is the command. Here it is not updating the time. Maybe this router is synchronizing time with the NTP server. So we'll discuss this thing. So clock set is done. Okay. There are some advanced commands which we have to discuss with the routing. For example, there is a command show IP route. This command will display the routing table. But here it should not give any information because everything is just directly connected. If I run here show IP protocol, so this show IP protocol will give you the information about which protocol is running right now. So right now it is showing there is no protocol running. Show clock to check the time. Clock set. This is hours, minute, second. This is date, month and year. Show IP route. It will give you the routing table information. Show IP protocol. It will give you the current routing protocol information. There are lots of show commands.
So
But-
I noticed that you're doing all these after the pound symbol. Does that mean that you're in the privileged mode to run these
Right.
commands?
Right. Thing. Any confusion till now? Okay, if that is not working, then what I can do? Okay, you both of you have 32-bit operating system or 64-bit? Any idea?
64 on mine.
Okay.
Yeah, it's 64.
I'm sharing you one software.
And where did you send that to us?
On your email ID.
Okay, understood.
Daniel, your ID is daniel.b.gates@nasa.gov, right?
That is correct.
And Crick, you have crick.r.olson.nasa.gov.
Correct.
Okay. So on this mail, in both the mail ID, I share that software. So is there any confusion in these commands?
No.
And the same command will be in your books.
I was following along in the book while you were doing that.
What page was that, Kirk?
It's page 39 in the student guide.
Are you able to see my screen?
Yes.
So till now, according to the books, we discuss about the basic of the computer network, physical component of the network. We'll discuss about what is the firewall, what is the router, what is the switch, PC, printer, servers. Then topology we discussed, speed, cost, security, availability, scalability, reliability. So this is the formula to calculate the reliability of the network. So basically this thing we are discussing when we are discussing the network designing. So like if you want to calculate what is the availability of the network, so in that case, how you will calculate that thing, what is the formula? Number of minutes into the year minus number of minute downtime. Means whenever you troubleshoot anything, you are taking the downtime divided by the number of minutes in a year multiplied by 100. This is the formula to calculate the availability of the network. The topologies will discuss: bus topology, ring topology, star topology, and the mesh topology. Now, physical versus logical topology means if you have multiple paths, then which path is the best path? That best path is my virtual topology, and which is identified with the help of protocol. OSI reference model we discussed, TCP IP model we discussed, encapsulation and de-encapsulation will discuss. Here they are using L4 header, L3 header, L2 header. I use like application layer header, presentation layer header, session layer header. Local area network we discussed. Need of the switches we discussed, what are the basic property of the switch. IOS, this thing we are discussing right now. Cisco IOS CLI function. So user mode, which is the enable mode, privilege mode, global configuration mode, and interface configuration mode. So what is the interface configuration mode? If you want to assign IP address to the interface, then you have to enter into the interface, particular interface. So let's say you want to configure IP address to the serial 0 by 0. In that case, you have to go to the configuration mode and then you have to type interface serial 0 by 0 or 0 by 1, where you want to assign IP address. These are all privilege mode commands. So let's say if you want to configure something. So router, here you have to type config T, which is configure terminal. So you will be here. Config. This is known as global configuration mode. In global configuration mode, first command is host name. To change the host name of the device. So let's say I'm giving host name and then R1. And if you enter this thing, so your prompt will change R1 config. This way. Again, if you want to change the name, just type host name and the name, whatever name you want. Then next. For example, you have these two routers which are connected with serial link. Let's say R1 and R2. Serial 1 by 0. Serial 1 by 0. You can connect to any port And if you want to assign IP address to these interfaces. So let's say here I want to assign 12 network IP address. So I want to assign here 12.1, 12.2. So see what will be the full configuration. So firstly, on R1, you have to go to the config T. Inside the config T, you have to run a command interface serial 1/0. Now, this mode is known as privilege mode, interface mode, config if. Interface mode means you are into the particular this interface. So if you want to assign IP address to any interface, you have to enter into the interface. There you can assign IP space address, then 12.0.0.1, and then subnet mask. By default on the router, all layer 3 interfaces are shut down. By default, all the interfaces are shut down. So if you want to enable the interfaces, you have to run a command no shutdown. Okay. Now, router 1 to router 2, we are connecting with the serial cable. On the serial cable, one end will be DTE and one end will be DCE. DTE, DCE. On DCE end, you have to set clock rate. You have to set clock rate. To set the clock rate, there is a command clock rate and whatever clock rate you want. So let's say 64,000. So normally we are using 64,000. Clock rate is set only on DCE and interface. Then R2 config, same way, interface serial 1/0. You can assign IP address, and here you can assign 12.0.0.2 and no shut and exit. That will be the interface configuration. Clear this thing? Any confusion in that? See this configuration. If you have any doubt, then let me know.
Can we take a
How did you,
bathroom break?
sorry, go ahead, Daniel.
No, ask your question. I was going to ask if we could take a 5-minute bathroom.
So how did you get from the R1 interface to the R2 interface? I saw you did the command interface.
See, these are the two different console. I just write on the same page. If you click on R1,
so you didn't.
He logged in. He logged into the
two
section
different
interface.
consoles. You didn't switch from one to another.
right.
Okay, sorry, I was confused. I thought maybe you switched to a different con. Okay, thank you.
Yeah, yeah.
You're just showing us that for the one that has the DCE connection, you have to set the clock rate.
Yes, on DCE, data communication equipment.
Right.
On this interface, you have to set the clock rate.
Okay.
So once this packet tracer is done, then I will show you this lab and you have to perform this lab. So it is just showing 3 minutes are remaining in uploading.
Kirk, have you received that email yet?
No,
It
requires 3 minutes to upload.
Oh, okay. Sorry, I missed that.
I'm just uploading that thing.
Would now be a good time to take a quick break?
Okay, not an issue.
5 minutes?
5 minutes. So this is your enable mode, right? So in enable mode, your first command is enable. This mode is your privilege mode. So here try to run all the show commands, whatever command we discussed till now. So first command is show version. You can see your version is 12.2. Clear that thing? No. I'm asking, are you getting the version?
Oh, sorry. Yeah.
12.2. Okay. Next command is show flash. Okay. So when we are running this command into the Cisco labs, that command is not working because those devices are virtual devices, IOU devices. That's why we are unable to run that command. But here that command is working. So if you see here, there is a file C2600-i-mz.122-28.bin. So this is my router image, ISO image. Clear this thing? Next command is show running configuration. Show running -config. You can press tab. You type, I think so, equal. So this is your running configuration. Press enter. So it will give you that complete information link, whatever configuration is present on the device right now. Press Ctrl Z. You will be out from this.
Control what?
Ctrl Z.
I'm not understanding. Control what?
Control and Z keyword. Otherwise, press spacebar. Once again, spacebar. Okay. Next command is show startup config. Show a startup. You can press tab. Enter. So it is telling startup configuration is not present. Why? Because we haven't saved anything. Once we save the configuration, then running configuration will become the startup configuration. So to save the configuration, there is a command copy. Type copy space run space startup. Enter.
Startup config or just startup?
No, startup config. Enter.
Okay.
Enter. So this is the command to save the configuration. Copy space run space startup configuration. Run means running config. Copy space running config space startup configuration. So whatever is present into the running configuration, that will be copied into the startup config. So now press once again show startup config. You can use up arrow key. It will work. Okay. So now it is showing you all the things. Clear that thing? Okay. Next command we discuss show history. So it is showing all the last command. The next command we discuss about show clock. So you can see the time is not correct. So you can change the time. Clock space set space. Firstly, you have to give hours.
Say what?
Hours. Time in hours. Like let's say right now it on your screen it is showing 4:53.
Yes.
So 04 colon.
Hours. Sorry, I'm sorry, I was misunderstanding what you're saying.
Right. Then
4:50.
colon, double colon. Then minutes. Again colon. Seconds. You can give any. Space. Then you have to give date.
In what format?
Numeric format. Okay. Not this way. No. Let's say today is 20th, right? So give 20 space August AUG space 2018. Enter. Clear this thing. Again run show clock. Clear now? Your time is changed.
How do you change it from UTC?
You can change that. Time zone is the command. We can change that thing. Okay. Next, run the command show IP route. Show space IP route.
IPO?
IP space route.
Oh, IP space route.
Enter. So right now it is not showing anything because we haven't run any routing protocol till now. Next command show space IP space interface space brief. Space brief. Enter. So it is showing you how many interfaces are there, and right now we haven't assigned any IP address to any interface. Clear this thing? Any confusion? Okay, you connect two routers with the help of serial cable. So if you want to know my end is DT or DCE, so you can run a command show controllers and space space bar. It will be long output. Okay, show controller and then serial show controller space serial 1/0. Enter. So see under your command, the third line it is showing DCE v.35, right?
Yes. With no clock.
Yeah. So it is showing you your end is DCE and clock rate is not set. If you run the same command on another router, you will get their DTE. Clear this? Okay. Now your next task is you have to configure the IP addressing on the interfaces. Crick, are you following us?
Yes, I am.
Okay. So so first thing, go to the config mode, config space T. Okay. Firstly, change the host name of this router. Host name. And whatever name you want to give to this router, space, and whatever name you want to give this router. Enter. So name will change. Clear? Next one, we have to assign IP address to the interface which is connected to the another router. So firstly, you have to enter into the interface mode. So now type interface and the name of interface. Let's say serial 1/0.
Space or no space?
Space. Serial 1/0. Enter. So you can see your mode is changed. Now you are into the config-if. So that is your interface mode.
So I just have a question really quick. On the
Right.
command line, I noticed Daniel did not put a space between the word serial and the 1, 0,
Huh?
and I did, and it did the same thing. Does that matter normally or no?
No, it doesn't matter.
Okay.
Now here we have to assign IP address. So on this interface, I want to assign IP address, let's say 12.0.0.1. So the command will be IP space address,
What was the IP address?
IP space address, type address, address is the command,
Oh, okay.
space 12.0.0.1, 1 space subnet mask. So whatever subnet mask, no, type subnet mask like 255.0.0.0. Hold on now. You are using class A IP address and here you are typing class C subnet mask. You can use that, not an issue, okay? But right now we are using /8. So you can use 255.0.0.0. Enter now. Okay. Then press type here clock space rate space 64,000 and enter. And then type here no shutdown, no space shutdown. Enter. Exit. If you want to exit from here, once again exit. Enter. Okay. So you configured on one router, DG router. So type here show IP space interface brief. IP interface brief.
Is there a space between IP and interface?
Yeah. Show space IP space interface space brief. Now see your output. So you assign the IP address on the serial 1/0. IP address is assigned. You assign manual IP addressing, yes, but it is showing status is down and the protocol is down. Why? Because the cable which is connecting to the neighboring device, that neighboring device is shut down right now. Okay, so just minimize this window and open the console of another router. No. Enable config T.
Config what?
Config space T. Configure terminal. Then create, assign a host name, and whatever name you want to give here.
I'm not going to remember all those lines, I can tell you right now.
Host name space any name. You can choose any name. Enter. Name is change. Now go to the interface serial 1/0. Interface. Firstly type interface. So 12.1 we assign on DG router. So here we have to assign 12.2. So IP space address space 12.0.0.2 space 255.0.0.0. Enter. No shutdown. Exit from there. It is the DTE and that's why we are not setting any clock rate here. Exit from there. If you want to verify that thing, you can run here show controller serial 1/0. Exit from there. Exit from there first because you are into the configuration mode. Enter. Show controller serial 1/0. You can see your end is DTE. That's why we are not sending any clock rate. Okay. So it is automatically sync with the DCE. Okay. So press space bar here. So now here show IP space interface brief. No. We have to run once again because that command is not here. Show IP interface brief. So this time your interface is up and up. If you go to the DG router, you will see up and up. Minimize this window and see the DG router. This green dot is representing your interface is working fine now. Clear this thing? Any question till now?